So good afternoon, everybody. My name is Boelo Schuur. I'm the Scientific Vice President of the EFCE, and I've recently joined the board of the EFCE, and it is an honor for me to serve the chemical engineering community in this role. As a Scientific Vice President, it is my role to support our sections and working parties in their goals to promote chemical engineering for the chemical engineering community and also for the wider society throughout Europe and through the world. I'm a chemical engineer by training, and I grew up in the north of the Netherlands. And next to a master's and a PhD degree in chemical engineering, I also hold a degree in chemical education. After spending, sorry, is somebody else not muted? After spending some time in Eindhoven and the United States, I joined in 2011 the University of Twente, where I'm now a full professor in sustainable separation technology. Next to my academic career, I'm also a program director at the Institute for Sustainable Process Technology. And in this role, I combine academics with industry. And it is my role to connect the industry and to hope not to break the ties, but instead tighten the bond between industry and academia. I think it is very important that we work on a sustainable future together. And in this sustainable future, education is a key part. In this coming 2 weeks, or the 2 weeks that are ongoing, we have a number of activities, and this spotlight talk is one of the series. We organized this for the 5th time, and we started during the COVID pandemic. And due to the success, we have continued organizing this next to in-person events that, again, next year we will have a European Conference on Chemical Engineering, and we have for every working party activities, but also here these online activities. This year we have sessions by the working parties on thermodynamics, membrane engineering, static electricity, drying, fluid separations, loss prevention, crystallization, process intensification, chemical reaction engineering, and food. And right now we have a session on education and digitization of education. The EFCE promotes scientific collaboration and supports the work of chemical engineers in more than 30 countries. We represent over 100,000 chemical engineers, and our working parties and sections cover the wide range of chemical engineering topics. And the sections and the working parties are the core of our organization. So before concluding, I would like to thank the participants of this webinar, the speakers, for their hard work and the promotion of chemical engineering. And of course, in that, I also include Martina Poo, who set up the whole webinar series. For now, I would like to give the word to Professor Hermann Feise, former EFCE president and the chair of this session. Hermann, the floor is yours.
Thank you, Boelo. Well, welcome everybody to this session on digitalization in chemical engineering education. And yes, thank you, Martin, for initiating this several years ago. This session likes to get you a bit into this kind of newish world where not only machines have a digital twin, but also students. I know we kind of feel weird about that, but you will see that when teachers can have digital twins, then students can, and that there are all kinds of things we can do that we cannot maybe even imagine today. My name is Hermann Feise. I work for BASF in Ludwigshafen, down in the wonderful Rhine Valley in the southwest of Germany, as their sustainability manager for their battery materials business. And as Boelo said, I've been involved with EFCE for a while now, finishing as the EFCE president in 2021. This session is very full. It had a lot of interest from presenters and also had a lot of interest from the audience. So I'm very pleased to have 7 presentations here today. We will follow the sun, starting with the colleagues from Australia who are with us after their dinner. Thank you for coming over. Going through Europe all the way to the US, where it's still very early in the morning and probably would be before my first coffee. And I trust that you don't want really to hear me talk. So I would go right into the business, even if we are 4 minutes early. Our first presentation will be on strategies of working with AI teaching assistants. Did I talk about digital twins? And it will be from Stuart Prescott. Stuart is a professor at the School of Chemical Engineering at the University of New South Wales in Sydney. And in his daytime, he actually looks at molecules and not as AI assistants. But Stuart, tell us about the assistants. Oh, sorry, forget 2 things. First of all, if you want to ask the presenters a question, use the Q&A or FNA or Q&R or whatever button chat it is down there. We'll monitor that. The other one we will not monitor, so your question might get lost. And for the presenters, if my camera comes back on, you're probably out of time. Thank you.
Excellent. Thank you very much, Hermann. So as Hermann said, my name is Stuart Prescott. I'm from the University of New South Wales in Sydney. And the work that I'd like to talk to you today about is stuff that we have done in conjunction with 2 of my colleagues, Dr. May Lim and Associate Professor Patrick Spicer, who are also with me in chemical engineering. So what I'm looking at is how we can make use of AI as a teaching assistant, as a multiplying force within our classroom, some of the strengths of current generative AI, and also thinking therefore about what tasks can we ask the AI to do well, that we can have some confidence that it will indeed do to a satisfactory standard, and we can be comfortable with letting it loose onto our students. And I want to wander through 4 short vignettes of some places where we have used AI to supervise design teams, where we have used AI as a writing coach, particularly for non-technical writing, where we have used AI as a quick personal tutor for some coding tasks in process modeling, and where we've used actually the AI as an assistant for the academic rather than assistant for the students in writing things like course learning outcomes. So that's what a quick survey of what we will look through over the coming 20 minutes. So I'm going to be talking mostly about large language models as generative AI. There are obviously other ways of approaching the AI story these days. We've seen them emerge into our consciousness and then into popular news articles and the like in the last 18 months or so, as things like ChatGPT appeared on the scene and gave us access to a large language model which was trained on a huge corpus of data. And there are various different technological improvements that have been released into the public since that was first released late 2022. Now, we know that these models are basically playing statistics with words, and so they are coming up with ideas about what word is most likely to come next given the current sequence. And it's slightly more sophisticated than that, but to a first approximation, it's about statistics of words. Now, we can get something back out of the language model, and this is the generative AI sense that was important to us, by giving it a prompt. A prompt meaning that we are asking it to do something. And so it's this word completion game. I give you an instruction, you give me an answer back. And there's some skill required to design prompts. It's an iterative process. It looks like design work, and it's now called prompt engineering. So this is the space that we are operating in within all the things that we're asking it to do. Now, when we're making use of these large language models, we are basically universally using somebody else's computer. We politely call it the cloud. Remember, there is no such thing as the cloud. It's always just somebody else's computer. And that means that you are giving somebody else data. You are giving somebody else access to what your students or what you are doing. There are potentially legal and privacy issues with that. There can also be some interesting technical issues in actually integrating somebody else's computer with what you're trying to do in your computer. Now, this is not insoluble. It just requires a word of caution. There are ways of running LLMs on your own infrastructure. It tends to be a bit more complicated and doesn't always perform as well as outsourcing it. That's a typical trade-off. Now, in terms of running large language models on somebody else's computer, we have three main interfaces that we'll explore today. And we'll see this from, I think, all the presentations as well. There is the web interface to things. So this is like giving a prompt to ChatGPT in its website. You ask it to do something, it gives you a response back. There are software integrations, and there are software integrations, for instance, with Zoom that we are hosted in today, but you can ask through Zoom plugins to read and summarize an entire meeting for you and to give you, these were the action items at the end of a meeting. There are also then custom built tools, such as plugins into learning management systems, which can go off and talk to an LLM and come back with some feedback for you. So we'll look at various different options on all of those today. Now, we've got to be a bit careful about what we do with large language models because they are playing probabilities with words. And so they are, to an extent, stochastic parrots. There's an element of randomness to them, which in information theory, information entropy, is related to how random, how unlikely the subsequent words might be to be chosen. And when you want creativity, then that temperature parameter is good, and random words appearing sometimes looks like creativity. When, however, you want it to have sharp, carefully honed facts, then that creativity can sometimes look like what is called a hallucination. Now, others will talk more, I think, about what the strengths and weaknesses and ways of getting around that and trying to build in actual domain knowledge into what the large language model is doing. We're taking a bit of a reductionist approach here and saying that this language model approach about word statistics is particularly good at recognizing things like styles. It's good at analyzing some text and saying, this is stylistically not what was expected or is what was expected. And this is how you can improve it. This is how you can extract some information out of it. And so each of these examples will be to an extent non-technical. It's about the professional skills rather than the technical skills of what's being taught, but it's about mostly about textual and style analysis. Okay, so the first one is a design course that we have with our second year students. They are undertaking some human-centric design, some user-focused design, and they're working in teams. And like all groups of student teams, and dare I say, all groups of professional engineers, or many groups of professional engineers, what we want the engineer to do, the technical person, is to go and do the user research, to define the problem well, then to think about the technical aspects of potential solutions, prototypes, and testing it out. Unfortunately, of course, what student groups tend to do, and many professional engineers, is as soon as they hear about the problem space, they're already thinking about possible technical solutions. And that's the wrong way about doing that. So trying to, particularly in a design thinking course, trying to constrain the students so that they start by doing this user research and problem definition step is important, because otherwise the entire stack falls in a heap because it doesn't actually have the foundations that are required. Now, when we're doing this with some hundreds of students in a large design course, that doesn't scale particularly well with teaching assistants. We need to spot where the design process is going wrong based on the interactions that we can see within the teams. And my colleague, Dr. Mei Lim, developed this structure within the course last year as she was teaching it. So each team was working in its own private space, and that private space was actually defined as the space for all meetings. Even face-to-face meetings would end up going via the Teams meeting, effectively, because that gives us a transcript. And once you've got a transcript, you can start to do textual analysis. So we do things like set up the meetings to be automatically recorded. They can get added to physical spaces via our meeting rooms. The recording in Teams can be set to automatically give you a transcript, a VTT file. Now, that VTT file is a transcript of who said what, and it's time-coded and the like with when. But the nice thing is that you can now feed that into your language model with a prompt. And here's a sample of one of the prompts that was used. You can ask that you can see that it's asking the language model to go through the summary of go through the transcript of the meeting and generate a summary which contains some things like, as an abstract, as an executive summary, what was talked about in this meeting, who was there, who agreed to do what unanswered items there were for either follow-up or questions back to the human teachers for the class. And then for the purposes of looking at which students are contributing well to the team, try and line up who is contributing to the meeting. So the instructor is able to see a transcript or an annotated transcript, a summary of the meeting. And this is fed back into the team as well, so that they can see this is sort of how you are operating as a team. It's a nice set of records for them, minutes for their meeting effectively. Now, the way we use that, though, is not to make the AI guess whether things are going wrong, but we use this to ask to let a human quickly and easily skim through the meeting notes to say, yes, this team is on track, or no, some intervention is required for this team. And so we have, for instance, a summary of the discussion, the actions for what attendees agreed to do which, follow-ups, questions, contributions, and the like. Now, this means that it's a 2 or 3 minute job to skim read through the summary of the meeting, as opposed to sitting through a 1 or 2 hour meeting from the students, or asking them to come and do a quick stand-up every single week to explain what they're up to and scheduling the time for that. So the AI tool is not replacing the instructor, but it is able to highlight which teams might be going off the rails and where you should intervene to try and get them back onto track, so that you don't get to the end of term and find them failing because they've done the wrong thing for weeks. Now, once the team progresses and makes good progress towards the goals of their design project, we ask them to do things like a group presentation. Now, what we want is for students to develop a presentation where everybody knows everything about what's going on. It's a well-integrated presentation. All students have achieved the learning outcomes, and they've been able to wander around and process everything, and everybody has a good understanding. What we get, of course, is highly optimized student behavior. Students are awesome optimizers, much better than any numerical methods code I've ever seen. They will be able to look at a problem and split it up amongst themselves. And this student does 2 slides, this student does another slide, another student does another 2 slides, and they throw something together at the end that is not integrated and is actually not the work of a team. It's a work of a loosely bunched group of individuals. They haven't actually achieved more than the team would achieve either in doing so. So to get that professional behavior where the students actually understand and are aware of the entire presentation and not just their own individual contribution, we have tried this idea of a matrix set of presentations. Now, to do this, we can make use of some of our lovely spaces that we have at UNSW, where we have quite a few teaching spaces which would describe as active learning spaces. It's a set of tables, yes, but on each table there's a separately controlled screen that the students can plug into to give a presentation. In a hybrid or online sense, there are actually also microphones that can connect off to other classes elsewhere. But we can see that this particular room is set up so that 8 concurrent presentations can go on with so 6 or 7 students collected around each of those 8 pods. So we split the students up so that each pod has 1 member of each team. So we might start with a set of teams that have been working on this design project, but rather than each pod containing 1 team, we instead split them up so that each pod contains a student representative from each team. And then we ask each team to present, each member of each team to present. So to start with, Team A people on all pods present. And so each student actually has to give the whole presentation, not just one aspect of it. While that student is giving the presentation, everybody else is providing some peer feedback on how they've gone. And then we can move through the sequence. So each team in turn, each is presenting, but it means that every single student is presenting the entire presentation. Now, we then have this actually also coupled into local Teams meetings, which are once again taking our transcripts. And at the end of the session, we can now start to do a textual analysis on those transcripts. So we get some giant pile of words that look like this. And you can see that up the top, this is all nonsense. This is just the idle chatter between the students to begin with. It's being picked up on the presenter's microphone, not an audience microphone. But we can see there's all sorts of nonsense being talked by the students as they're making fun of each other for having trouble with a computer and everything else going on. They're a bunch of friends who are having a bit of chatter. But you can see below that blue line there, the students are getting into the presentation. The language model can actually spot that the presentation has started at, all right, good afternoon, everyone, and doesn't include everything before that in its analysis, in its textual analysis. So that doesn't seem to affect the output that we get from it. So we have a nice long presentation. The students they've documented that all. We then can get, the language model is asked to provide a summary, and it's asked to provide a summary against a list of marking rubric criteria. Now, a rubric would normally be a number of criteria with a level of achievement. We've not yet managed to get the level of achievement measurement to work particularly well, but in this formative assessment, that's not an issue for us. What we have been able to do is to have the language model identify where particular aspects have been talked about in the presentation and to summarize them. So as a summarization tool, it's working well. And each of these problem 1, problem 2, solution 1, solution 2, etc. aspects are the criteria of our rubric. Just hasn't been quantified. That's fine for our formative assessment. So what ends up happening is we end up with this huge matrix of feedback from every student and for every student. And so what we can end up with here is a set of feedback that has been written by each student about one presentation. And we also then have the AI-generated summary of each presentation, all collected together in a tool called Padlet. The Padlet's actually able to be exported as a spreadsheet for further analysis, and summaries can be generated and fed to the students. You can see that some of the students have actually started to have a bit of conversation there about the feedback that they have received and about what has been going on in these presentations. So it's quite a rich venue for getting feedback from peer feedback as well as the AI feedback. And then, of course, there's instructor feedback kicks in later as well in this scenario. Now, this is only a fairly limited trial. We did ask the students what they thought of the AI-generated feedback, and their feedback about the AI-generated stuff was actually quite good. You can see that most of the students felt that the feedback was contextualized well for them. They understood what they should take away from it. They valued that feedback. They understood that it was maybe limited, but they could see that there was value in it. There were times when the AI feedback missed things that they had done, but they were able to say, but I did it. And they understand that maybe that feedback from the AI is imperfect, but they've still got something valuable out of it. They actually also found that it was equally as valuable as tutor feedback, partly because it arrived so much faster. It was a matter of minutes to hours to get back all of this feedback from all these people, whereas the human feedback was typically much slower. So they were comfortable and happy with the feedback. The peer feedback was actually often a bit more brutal in its assessment of each other, whereas the AI was a bit more polite. And I think that was the other reason why they liked the AI feedback. Okay, so we talked a lot about getting students to write feedback, but teaching them about the genre of writing feedback is also something that we have found that our students struggle with. Feedback and also self-reflection work is not something that a lot of technical people are that comfortable with, and a fair bit of effort at training them into that is required. So a particular context we had was to a master's course that I teach with Pat Spicer in complex fluids. We have a lot of different cohorts in this particular course, some of whom we have trained over the course of years to write a lot of feedback, but some of whom are new to UNSW and are not very good at writing feedback at all. And they do not understand the expectations around that. So when we're asking the students to write feedback, what we're wanting them to generate is supportive, useful comments actionable comments on how to improve work. But what we tend to get is incredibly short, such that it's meaningless, summaries of what was there rather than ways of improving what was there. So to try and improve this with our students, we built a simple AI tool into the feedback cycle. So what we originally had was a video submission. Students would provide feedback. We would actually assess that feedback for its quality, and that was part of the mark that the students got for their quality of feedback. And that was then recorded in the gradebook. Now, this feedback step here was the one that was going wrong. And so what we did was build in an extra step to it. And we hacked into our LMS Moodle and with some JavaScript hooks, a way where the student is able to ask for some critique of their feedback, which pops off to the OpenAI LLM via so our own custom Python code and the OpenAI API. And then it gives them some information about their feedback, asks them what they would like to change. They can have a chance to edit it before submitting it. And we're finding that this is actually working quite well. So here's sort of what it looks like in practice. For those who don't know the Moodle user interface, we have our overall feedback here. We have what the student has written, and we have some get comments. And then the AI trainer, the LLM, comes back after a suitable prompt and says, this is what you did well. This is how you could improve what you've written. And here's a bit of a summary, but some takeaways for you for your professional future. Now, we've been playing around with this actually fairly recently. This is actually currently open right now for our students. And as of about an hour ago, actually it's gone up. It's gone up by 40% in the last hour. As of about an hour ago, it had cost us a whole 5 US cents for us to be able to analyze an amazing amount of work from our students. So this is helping us greatly in working our way through what we want to see. In coding tasks, we find that our students get stuck on understanding the code that we've given them. And so this is where our nice little button which says, explain this code, is really, really helpful to us. This is built into the Jupyter notebooks hosted on cocalc.com that we use in our process modeling course. And we're able to then make good use of that for getting hold of, first of all, explanations of how the code works. But secondly, when I get an error message, what do I do about that? Now, I can see that Hermann has appeared, so let me just leave you with some final thoughts, and that is that our AI here is a multiplying force for us. It's great at providing lots of quick feedback. It's not perfect, but that's just a risk assessment around what it can do well and how we use it. I think it's important for us to not outsource work that can meaningfully be done better by a student to the AI, but in places where we know that we don't have the capacity to review thousands of pieces of feedback and give meaningful comments on them, we're never going to do that. So getting the AI to do that for us is better. So at this stage, I think Hermann's going to coordinate some questions and answers. So I'll pass back to you, Hermann. You're still muted there. So one of the questions online there was about a quick question online has just come through in the chat about the ethical aspects of submitting input to an LLM. So we're not actually inside the EU, so we have some other ways of dealing with these things. We have our own local laws, obviously, so it's not GDPR questions. The ethical questions are important ones. So we do have access to some of this via our own private cloud. So UNSW's own private Azure cloud is able to do some of this for us without it going all into the open. For some of this, we are able to, and likewise some of the other tools. For some of the tools, the data sharing agreement with the tool is actually fairly well established, and we're comfortable with that. But you're right, the questioner is correct that there are lots of issues with us feeding information straight off into LLMs and leaking lots of personal information. So we generally do warn the students that this is what they're doing. The getting feedback on the AI trainer, for example, was getting feedback from the AI trainer was, for instance, something that we had the students were doing voluntarily. So there wasn't sort of an issue there. I think so. I'll just pop this as a slide up, in one of the ways of answering that question is that there's a simple framework that May has developed, and she uses this with staff as well as with students, and that is a set of questions of, could you use AI, and should you use AI, and would you use AI? And sort of, if you were using it in the back end without telling people, and then it came out that you were just pretending to mark all this work and the AI was actually marking it, people would be a bit annoyed with you. So it's there's sort of a could you, would you, should you framework, which helps us start to address these ethical issues as well, I think.
All right. Thank you, Stuart. There was a comment from Yarka, which just basically a thank you. If there's any other question, please use the F&A or Q&R or whatever it's called in your language tool. If there is not, I have one more question for you, Stuart. In your first example, you're basically surveilling your students all the time when they work on this. Does that change how they behave?
That's an interesting question. The students, when you read the transcripts, the students seem pretty relaxed about it. And I think it would be a potential. We're only using this for formative assessment. Well, not even assessment, for formative assistance to the students. So I think it's kind of important that's an important part of it. UNSW actually has a policy to not make use of various different proctoring, e-proctoring and AI proctoring, and even personal proctoring services that other universities use, because it's a bit creepy, and we didn't want to subject our students to that right back to 2020. And we just said no to that as a thing to do to our students. So yeah, we're quite conscious of that as being something that we don't want to go down. Looking at the interactions in that Jane Doe example there was one of that transcript. That's a real transcript from one of the interviews. It doesn't seem to change their behavior, because you can still see the same interactions that you'd have if you were in the room, with them telling jokes to each other, with them giving each other some feedback, shall we say, about stuffing up the microphone or whatever else, making fun of each other. You can see that there's a very, very casual set of interactions still there. So it doesn't seem to have changed what they do in the way that we might expect.
All right. Well, thank you, Stuart. Thank you for a really cool start of this session, this Spotlight Talks. If you still have questions to Stuart, feel free to type them into the F&A while I invite Christopher Honig to give his presentation. Christopher is a senior lecturer, also from down under, in chemical engineering in Melbourne. I hope I got that right. And we're getting into one of the focus points of this Spotlight Talk session here, where it's about games. Christopher, we can see your edit screen.
Okay now.
And now we see your presentation stream. Chris, the floor is yours.
Thank you, Herman. I will be speaking about gamification. It's going to be a theme for the evening. I'm very excited about AI as well. And there's so many applications in education. I will speak to that a little bit as well. Broadly, AI and GPTs in chemical engineering, I think everyone here can appreciate it's going to could potentially have a transformative effect. We've all seen that GPTs are excellent at generating English language or any language coding as well. The average vocabulary for a native English speaker is anywhere up to, say, 35,000 words. You think about a piping and instrumentation diagram, and it doesn't have 35,000 symbols. It has a symbolic lexicon of, perhaps 200 symbols, maybe 100. So, the opportunities there for a tool that can do predictive design work, for layouts that can cross-check your design calculations or your P&ID layout, do immediate proofreading and things like that. I mean, we can all see applications like that. So it's a very, very exciting time, particularly to be in education because of all these new tools that are coming out. So I've got DALL-E to draw me just a dumb comic, but I'm in this AI cult, I think. So anyway, my name's Chris Honig. I'm a senior lecturer in chemical engineering at the University of Melbourne. So similar to Stuart, we are speaking very late in the evening. But thank you for hosting us. I'll just quickly cover teaching about GPTs and then move on to some cool game-based activities that we're doing with GPTs. But just quickly, and I've got Martine to help me in the background. If you could, Martine, if you could please post that point 2 that I sent you before the first link, but the second. Oh, excellent, thank you. I gave a whole series of lectures on using GPTs in chemical engineering last year. And I simply want to share those resources. So some of the things that we've covered, what are LLMs, the privacy and ethics of AI, the limits of the tool, and how to start off doing prompt engineering, coding with ChatGPT, all these kinds of things. I'm not going to cover it here. I'm just going to say there's a link. Please feel free to steal if you're at another university or another educator. Probably everybody here has given a similar class to that, or they know someone who has. I just want to share my resources and say, hopefully there's something in there that might be useful for you. Feel free to steal. And then I will just try and, if this video doesn't work, Herman, please jump in and tell me. I'm doing my best, but it's always a bit of a risk over Zoom. As Stuart kind of covered, GPTs are excellent for coding. They're excellent for giving you a breakdown of where there are errors, and they're excellent for generating code for you. And I think that's very useful for educators in chemical engineering because most chemical engineering programs don't focus on coding. I mean, if you compare it to computer science or electrical engineering or something like that. And the great thing is you don't need to know how to code anymore because GPTs can do it for you. So I'll just show you this little video from the CEO of NVIDIA talking about how he sees the future in coding. And if it doesn't work, Herman, please tell me.
I want to say something, and it's going to sound completely opposite of what people feel. Over the course of the last 10 years, 15 years, almost everybody who sits on a stage like this would tell you it is vital that your children learn computer science. Everybody should learn how to program. And in fact, it's almost exactly the opposite. It is our job to create computing technology such that nobody has to program and that the programming language is human. Everybody in the world is now a programmer. This is the miracle of artificial intelligence. The countries, the people that understand how to solve a domain problem in digital biology or in education of young people or in manufacturing or in farming, those people who understand domain expertise now can utilize technology that is readily available to you. You now have a computer that will do what you tell it to do. It is vital that we upskill everyone, and the upskilling process, I believe, will be delightful.
I'm not going to cover
surprising.
The resources that we have here, but I just simply echo that sentiment. I think it's very exciting. I think that domain expertise like chemical engineering or education about chemical engineering, combined with what GPTs can now do, particularly in coding, it opens up a whole new range of opportunities. It's all of our students graduating from our degree this year. Last year, they would have had fairly low-level coding ability. This year, we've taught them how to use GPTs for coding, and all of them will come out as basically okay mid-level programmers. And I think that's an amazing jump. So we've got a 3-hour workshop resources that I've provided through that link. And I hope that's useful. Please feel free to use them. It's very coding activities geared towards common chemical engineering applications. So please feel free to steal. I want to keep moving. Teaching with GPTs. Now, so
I want to say,
a bit like Stuart before, we've built a whole range of custom GPT wrappers or custom GPT use cases. One that I'd like to just briefly mention is industry consultants. So when we do look at safety case studies, one of the things we like to do Melbourne Uni is bring in semi-retired, or they've kind of just hit retirement age, but chemical engineers never really retire. They just kind of potter about. So we bring in those kinds of people who aren't working full-time anymore, but have this wealth of intellectual capital and experience. And we bring them in and we ask them to speak on a safety case study seminal in their 45-year career, let's say. So just pulling two examples that came in last year. On the left is John. He was the senior process engineer at the Shell middle distillate facility, the middle distillate synthesis facility in Bintulu. They had an air separation unit explode in 1997. So this photo, he got in a lot of trouble for doing this, but he took photos of the explosion immediately after it happened. And amazingly, no one was killed, but most of the facility was taken out. And then on the right, we have Nick. He completed his PhD on oil platform safety. And I think he finished about 2 months before Piper Alpha in 1988. And so he was one of the investigators in the Cullen inquiry. So each one of these semi-retired engineers speaks to that case study because they feel that's the one that they have the highest level of expertise in. And so what we do is we require students to research one of those two safety case studies for a report, and they do a Viva as well. And the consultants provide a 1-hour lecture and 30 minutes of consultations with student teams. Say there's 4 students in a team. Now, probably what everyone can expect is that there's something students always request, and it's always more time with the industry consultants, which of course I would love to provide, but there's limited resources in the subject, and the consultants have a limited amount of time they can dedicate. So what do we do? What are we to do? Well, this is where enter ChatGPT, right? So this is one of the things we built, was a GPT wrapper to role play as these consultants. So how do we do it? The consultants complete a detailed questionnaire about the safety case study, about their background. We ask them to write it in their plain language speaking style. That informs a system prompt for the GPT. And we also pull any publicly available information that we can get. So Piper Alpha is a very good example because there's all of the documentation from the Cullen inquiry. There's a whole range of articles that have been written about it. And we put that into, it's called a RAG, or a retrieval augmented generation. But it means that the GPT will search that information first to provide an answer rather than using its general knowledge training set. So that's how we basically structure it. And then the inevitable question I always get is, what about hallucinations? Everyone knows, Stuart touched on it, GPTs can give unreliable or nonsensical information sometimes. So how are you going to handle that? We do it by effectively, we're asking the GPT to role play as a person, not role play as a tutor. And it turns out, well, I mean, if you just think about it, a human being can say, I don't know, or they can say, that's outside of the scope of this discussion, or a human being can be wrong. And I'm not saying a human being can be wrong and a GPT can be wrong, therefore it cancels out. But I'm just simply saying that designing a GPT that can say, I don't know, or can be wrong in the same frequency and architecture as a human being, that is much, much easier than trying to design a GPT that is always going to be infallible and is always going to be compellable, meaning you can always ask it a question and it always does its best to give an answer. So those two conditions of infallibility and compellability, they're a very, very high threshold for anything to meet. A human being definitely couldn't meet that. And people tend to be I find they're very hard on technology. I'm not getting in a self-driving car unless you can prove to me that it's an order of magnitude better than a normal driver. It's that same kind of threshold that people apply here, which I'm not saying is unreasonable. So that's how we handle it, by designing it to role play as a person and being able to refuse answers. It makes it much easier for us to handle the issues of hallucinations. So here's a link to our chatbot, or like one early iteration of it. Have a play with it if you want to, and if anyone's interested in collaborating, we have a small grant for developing new tools, so please feel free to reach out. I'd love to work on any chemical engineering new tools or applications anyone might have. So evaluation, we don't want to do something like this without evaluating its learning efficacy. So how did it go? We've built a range of tools now, but I just thought I'd focus on this one. We looked at voluntary student use of the chatbot. It was very high, higher than I probably would have expected. So generally students were willing to try these new tools, which was quite cool. We did a mixed method sort of exploratory approach. So we began with interviews about the use of the tool, and then we developed a survey instrument that had qualitative and quantitative questions in there, and we validated the survey. But I won't go through all of that. We use a range of different question techniques, but the one everyone's familiar with is like a Likert survey. So pulling out the result that everyone sort of wants to jump to when I present this is asking students about their self-assessed learning outcomes. It offered a useful learning experience, and we got a 59% of the respondents agreed with that statement. So bearing in mind the response rate was quite low because it's just one class. So it's, a total class of about 70 students. So we had a 59% response rate, and actually a 59% agreed with that statement. So I would say that's okay as the first result. It's not outstanding. It's not terrible. It was just sort of somewhere in the middle for a first iteration GPT wrapper. We thought that was okay. And then we also mapped the student uptake to a theoretical scaffold called the Unified Theory of Acceptance and Use of Technology. So the logic here is, we're all presented with new software every single day, right? New apps, enterprise software that we can use. And we're constantly making value judgments about whether or not we're going to take the time to learn some new piece of software. The UTOUT offers these 4 constructs for understanding user uptake of new software. So it sort of says whether or not a user takes up a new piece of software is dependent on their performance expectancy, like how well they think this piece of software will work. Effort expectancy, how hard is it going to be to learn this new piece of software? Social influence, like what are my graduate employers telling me? What are my peers? What's the subject coordinator telling me? And facilitating conditions. How easy does the university or whatever institution make it for you to actually uptake this piece of software, right? So that's the way the UTOUT frames technology uptake. And note that most of the first 3 actually have nothing to do with the software itself. They're all about users or third parties' perceptions of the software, right? So that's interesting. Now, when we applied this to the use of our GPT-powered tool, it's not even close. There's one construct that emerges absolutely clearly, and it's performance expectancy. When you read through the qualitative feedback, it's like every second response from students is, I took it up, or I was going to try it, but I wasn't sure if it would be reliable. Students are constantly talking about hallucinations or the perception that the GPT might provide unreliable information. And I think that's a valid concern because we find that the frequency of incorrect information probably is no higher than the consultant themselves. But it's a very common narrative in the media about performance expectancy of GPTs. And I find it's a very, very common narrative inside of universities that a lot of academics will use performance expectancy as kind of a defeat or a discouragement to students using GPTs for, academic misconduct type of use cases. But, clearly GPTs have uses well beyond just academic integrity or misuse. There's a lot of productive uses in education as well. So it just highlights that risk of emphasizing the, problems with the GPT as a strategy for discouraging students from using it in the interest of academic integrity. So anyway, we found that was interesting. This was such an amazing result we discovered as well. We're never expecting this, but it turned out that we think there might be a minority of students who actually prefer to use the chatbot over in-person interviews. And we think it's emerging because of concerns about a loss of face, because speaking to a consultant who they hold in high esteem and asking them in front of a small group of other people, that can be quite confronting for some students, or it can be for students that are introverted or feel difficult, have difficulty speaking in public, that can present a barrier to their participation in the activity. So this was so interesting. We identified it in some of the initial interviews, and we designed some questions for it. I'm going to emphasize that our N is very small, so we don't have a lot of statistical power in the result, but it hints at the possible futures for GPT teaching tools, that they might be able to get around some barriers to learning. So I'll just show the result. I felt comfortable asking questions during the consultation, and the majority of students agree or strongly agree with that statement. I felt more comfortable asking an AI consultant chatbot questions compared to a real consultant, and it splits the responses much more broadly. So I'm sort of arguing, or we believe that this is probably a very subtle effect. It's very, it's some students have a slight preference, but it's not that they are actively avoiding these consultation meetings necessarily. But it just hints at, it's something we just conceived of the AI chatbot as just an inferior tool that would resolve the issue of scalability in our teaching, but we just kind of uncovered this by accident, this small subgroup that seems to actually prefer it. So anyway, we just found that amazing result. I'll just move on. So that's everything I wanted to talk about in terms of GPTs. I just really wanted to run some quick ads at the end for game-based learning activities that we are trialing and we've had some success with. So this is part of a collaboration with Nottingham University. There's a third-party software. Some other people in the room might use it as well. It's called TSC Simulation. And basically, this is a great company. They provide a kind of, a DCS. They've been providing DCS simulators for a long time, but now they've also built these 3D virtual reality unit operations that you can walk around and control manually as well. So we have a student operate as an operator running around the plant, operating manual valves and things like that. And we have another student who can be in the control room, effectively running this unit operation. And, we do a whole range of activities at the beginning, an orientation activity and cold start and normal operation. But then there's also scenarios. You can build your own custom scenarios in the software or use their pre-built ones. Something goes wrong, and then students need to take corrective action to bring it back under control. And so we ran that last year, and we run it in a kind of examine simulation environment. So the students in a team of, say, 3 are operating the facility, each with defined roles, and then there's an examiner in the room observing their communication and their response to a disaster. So one of the scenarios can be like, well, you can see it here, there can be a major fire, for example, in a compressor or something like that. And students need to take corrective action, and they need to make decisions in real time and think through, immediately how to apply it. So it's a very authentic form of learning. This is part of an ongoing study because we've been trying to assess some of the learning outcomes from students using this software. But I just wanted to advertise it. I think it's a great piece of software if you can get it to work. And that was my only last point. It was very difficult for us to actually implement this software. It's a third-party provider. It's a very niche piece of software. But anyway, I wanted to advertise their tool, and I think more universities should be using it. Should be using these types of simulators. And then the last one, just a little plug. This is something coming soon. A chemical engineering inspired video game made as a mod to an existing game called Factorio that some people might be familiar with. But that's just something that I'm working on at the moment. So stay tuned. But some of the initial student responses to this have been very good. It's sort of a way of teaching students about chemical engineering without them actually realizing that they're learning, because they're having a lot of fun playing a video game at the same time. So Hermann hasn't popped up. I think I've gone a few seconds under my 20 minutes, but that's the end of my presentation. And thank you very much for your time.
Thank you, Chris. As always, please post your questions on the questions and answers, or Fragen und Antworten, in my screen. And Well, this is a very
This is an interesting question.
interesting question. We
In
need
Germany, sorry.
Chris, please read it. Yes.
So in Germany, as a student council, if a troubled student mentioned suicide plans, I should call the police such that the student is taken care of by officials. How would or should AI react? I'm not really sure how to answer that question. So that would be outside of the scope of a chatbot that we would design. So if I'm not, I don't know, Herman, am I missing some context here or something?
Yeah, I guess the question that is asked is a discussion between a tutor and a student always has many dimensions. And this is one that is non-technical, but it's, how you say, it raises a red flag immediately. The question is, if you rely on AI support for teaching, how do you deal with those dimensions that are not straight in the field?
Yeah, I think, well, this is a common question that's come up in our department, in our community of practice around AI, is I think some people are concerned that AI will, can it replace the job of a teacher? And I'm on the view that absolutely it will not replace the job of a university educator. It's simply there to supplement it. So I think you're absolutely right that, of course, you can kind of come up with technical solutions for how an AI might handle a situation like this, and it might immediately raise a flag, and it might immediately refer the student to counselling services and that kind of thing. But the broader role of pastoral care that's provided by teaching staff, of course, and I don't think that an AI will really do that in an effective way, in the same way that an AI can't be an effective like coach or something like that, because that interpersonal interaction is so essential. So if you're asking me about the tool that we've built, I think of it just like an interactive textbook. You can read a textbook and it's in a very linear fashion, or you can try to talk to the textbook. But a textbook's not going to give you, crisis advice, and when your girlfriend's broken up with you and or everything's going wrong in your life, and you're thinking about ending it all. The textbook will not be effective for that. The chatbot GPT that we've built will not be effective for that either. So yeah, I hope that helps address Marcel's question. Yeah. If you would like to add any further context, please feel free.
Yeah. Okay. We have a second question that asks whether the answers of the chatbot that replaced the consultants was actually cross-checked by the consultants and what they felt, how good they were.
Yeah, we tried. We did do that. They're not. I just want to emphasize, we're not replacing the consultants. We still use the consultants' time. We just try to supplement it. So if everyone gets a half-hour meeting with the consultant in the beginning, now they still get that half-hour meeting, but they also have this additional resource. So we did. There are problems with it. It's not. We do have. I'm not saying that it's infallible, but you have to understand that a human being is not infallible as well. And to be honest, when we're talking about safety, I'm not actually sure you want a GPT as a teaching tool that would be infallible, if in principle you could design it, because broadly we want to, we usually in safety, we want to train students to have a shared responsibility in safety all the time. A graduate engineer should not simply do something that they're told to by a senior manager that they believe to be unsafe simply because the senior manager has told them to do it. They should always be involved in the critical thinking around safety. And that's something that we would like to emphasize to them with this tool. It is fallible, or there can be errors, and you should exercise ongoing critical thought around the information that you're getting and continue to make your own decisions. So I'm not actually sure if I could build a tool like that was perfectly infallible. I'm not sure it would produce the learning outcomes that we would want. So anyway, I think it's a really
great wrap-up statement, actually. Wonderful. Well, there's one more. There are two more questions, and I'm sorry, but I need to relay you to the chat because
okay, no problem.
We have a very full. Well, thank you, Chris,
no worries,
for
thanks,
your contribution. And we'll change over to another subject, dealing with mixed realities and simulations, and it's from the CHARMING initial training networks here in Europe, which is one of the great lighthouses for digital learning in Europe. And its presentation is going to be given by Professor Thies Pfeiffer from the Hochschule in Emden-Leer in the north of Germany. Thies, I cannot see you on the screen, but I hope you're on here. Oh yeah.
Well, I'm on there.
Screen is on. Screen is yours.
Okay, thank you very much. And thank you very much for having me in this session. So yeah, I'm from Germany, from the Mixality Lab in Emden-Leer, and I was happy to be part of the CHARMING project for a long time, and we had some nice results, and some of them I want to share with you right now. So it's a little introduction to mixed reality for training, and I think we had a lot of infos on that already. So I want basically to give a flashlight on certain technologies, and also motivate a little bit why to use mixed reality training and what are the challenges that I see, very prominent challenges. And by giving some flashlights on 3 aspects, I want to discuss with you about the future and certain enabling steps. And this will be very much based on AR and VR, so I'll cover both aspects in the talk. But start with the motivation and challenges for mixed reality trainings. Well, in education, we face typically several challenges. One is that there's ever-increasing content, fast iterations, especially in particular domains. I'm from computer science, so we basically have every half a year we have new content that we need to transfer and deliver, especially in the field of AI at the moment. And on the other hand, we have a skilled worker shortage, no time to create the content, no time to have face-to-face interactions, and so on. And well, some of the materials that we are having in the e-learning domain lack quality and attractiveness. There are side fields of attraction like TikTok and other things that distract the attention of our learners, and we need to compete with that. And I see that there are some aspects of mixed reality that can hopefully help to compensate for that and make e-learning more attractive. I'm not so much arguing to say, okay, practical training, we want to get rid of that. No, it's more like, okay, we see benefits in e-learning and we want to move closer to practical training from the e-learning perspective. And some companies actually see that and have implemented here and there some trainings, some kind of lighthouse trainings, as we just heard. Okay, there is this training simulation, and yeah, but it can be used for certain aspects, but it's sometimes difficult to tailor it and tune it to your needs. And I'm a teacher myself. I know that I always have kind of my thinking is always a little bit different how to use material in with my particular group of learners. And so I want to be in power to actually change training programs to my needs and to my group, and to customize it, and that's often not possible. So computer-based training is something that came along years ago, and we saw benefits in there. And then we have web-based training, which all of a sudden reduces the burden of having these like computer rooms and special hardware dedicated to training facilities. Now we can basically do training while commuting and so on. So there are lots of benefits in this regard, but it's still like training on a kind of flat surface. It's like very abstract. You can do great things with quizzes and everything, but it's all like just hidden in this kind of 2D environments. There's not much about acting and training acting, and mixed reality-based trainings. They can kind of combine the advantages of web-based trainings, electronic trainings, and physical trainings, where you really have to perceive yourself, train your attention, dedicate attention to the specific aspects of the environment in the proper timing, and also actually have some spatial actions that you yourself have to do. So it's from an ego perspective. And this makes something with the trainee, if you're really feeling that you're in the situation, then contrasted to seeing a video of someone else being in the situation. It even goes as far as that you can train your muscle memory, body memory, also episodic memory, that you can, oh, last time when I was in the lab, compared to, okay, just seeing a video of someone being in the lab. So that's very crucial. But there are still challenges, and we heard about some challenges already. I've just covered some of them here. One is the broad challenge of media competences. So there's new technology, and it comes with a steep learning curve. And well, you should not require the students to acquire the competences to use the media technology at the same time while actually doing the first training. So not mixing two learning tasks basically within one session. So that's one thing. And learning is social. So typically, in many cases, we learn in social embeddings, just being in like two trainer and trainee, but typically as larger groups. And the standard VR technology, for example, we are using typically is more isolating the users. They are one in the VR headset, they don't see the others standing around, and there's no interaction with them or reduced interaction. So, but XR training should foster this communication. And there's lack of content. So we have quality content, but there's not much of them around. So if you want to implement XR technology in your curriculum large scale, then you might find 1, 2, 3 instances, but this will not cover just one course for half a year, and you have like several courses to cover. So there's a huge gap, and then it's questionable whether you want to invest in XR if they only have this one thing that you can use. So content creation for XR needs to be cheaper and faster, and authoring should be possible for educators so that you can tune your own content to your particular needs. And there are many operational challenges. Despite the costs that you have, it's also like you need space, the room, and if you are a school, then it's very difficult to see how you can scale up these kind of trainings to classroom, like laboratory classrooms or something like this. There are approaches, but it's still something that you need to learn how to handle with that. And I have to actually have the room and prepare the rooms for that. So these are kind of the onset of the challenges I want to address in this short talk, and give some insights from some of the projects and the insights we gained from CHARMING in particular. One is focusing on AR, and there we've created in the past within the CHARMING, in cooperation with the CHARMING project, but also other projects, the framework for authoring of augmented reality applications. I can just give you a glimpse of that. And the focus of this is to say, okay, it should be scalable. So it should work on the devices of the students and the teachers, so they don't need to learn new device usages and everything, so they can adapt and use familiar patterns of the operation. And on the same side, it should be enabling the teachers to actually create their own content and adapt content that is there to their needs. So fulfilling these kind of two visions. And this is why we created this authoring tool for smartphones. And you can see that there are some examples from chemistry, but there are also examples from other domains. I will present you with a short video where you can see the thing in action. So it's a kind of mild augmented reality. It's not that you detect something in the environment. We just place virtual objects in the environment. This is also on purpose because it should be scalable. So if we would rely on physical objects to be present, then you would have to have the physical properties. So you cannot just start with the training out of the box. Now with this solution, you have the smartphone in the pocket and you can do your training any place, anywhere. Here are some examples from the CHARMING project where we did this titration experiment. Even with like the logbook and everything that you can just, here you have your chemical lab in the pocket. You can get to use with the proper looking objects and on the machines and measuring instruments and everything. You even see the correct labels on the flasks that you can learn where to find the information of these that are relevant for you, and so on. So these are examples of scenarios that you can realize with this kind of training. And as I'm a computer scientist, I'm not a chemical engineer. So my focus in this work is reducing the burden of technology for educators in other fields like in chemistry to make use of this technology. So technology we provide should be easy in onboarding, so easy to learn. It should be easy to use, so it should have a clear kind of atomic set of interaction that you can use to implement your trainings. But it still should be powerful to be able to implement a huge variety of trainings. Now you should be able to give feedback, so it has several layers of feedback, and give you instructions in AR, and also have this kind of motoric training. So it's not just a computer game, but you really need to move around and do stuff and arrange your workplace and go to the proper locations in the lab and so on. I can just give you a glimpse of that. If there are papers out, if you want to get deeper into this material, but just to let you know, so this we have animations and texts to explain how it works. We have different basic interactions. We did some fancy stuff, but we ended up having the buttons that you can press because it's easy for users to see what they can do. You can get the highlights of the objects that you can actually make use of. And as I said, we have multiple layers of feedback. You get technical feedback of how to operate the AR device, get feedback on the objects that you can use. You can get these kind of avatar, like giving kind of a meta information, like a bystander or some virtual agent giving you some feedback. But if it's getting worse, then you can also can get the user out of the situation and use this kind of high-level feedback. And at the end, obviously, we have some summary feedback of the whole procedure implemented. And if you want to design and author these kind of trainings, then you can make use of these feedback components all over the place. And we actually did that in several scenarios also related to chemistry in CHARMING. And there are some papers out there where you can learn more about the particular scenarios that have been implemented for several stadiums of chemical engineering expertise, from the grammar school level to student level. If you want to build something yourself, then this tool is open source. So it's an open source authoring tool. And there's a link where you can find it. And you can also search on the internet on ChAR and Emden-Leer, and you will find it easily. So that's one way of dealing with that. And I hope that with this approach, we've tackled some of the media competence issues. There's known equipment, your smartphone, so it's lowering the barrier. Lack of content, so now it's an open source authoring tool where you can create the content, and maybe you can make your content also publicly available. That would be nice. Some of the content that we have created is actually available in the App Store today, so you can download an application for midwives training, for example. And there are some operational challenges tackled because it works on a small desk, so you can actually use it in a grammar school classroom, and every pupil owning a smartphone, bring your own device away, can make use of a small experimental setup. You don't need to clean up afterwards and so on. So lots of advantages with these kind of tiny scenarios. If you want to go large scale and go for VR, then there's also a way, and we are tackled with that. We are focusing on video-based 360 degrees videos to create these kind of non-linear training stories, we call them. This is an alternative to the 3D way of doing it with 3D animation and simulation, but this is more effortful if you go the 3D way, because you have to have experts to create the 3D materials and to learn about how to create the simulation and so on. Typically, they're not chemical engineers, and so they don't know about that. And the transfer of information between the experts of chemical engineering and the experts of media creation, that takes a lot of time and a lot of iterations. Here we follow a different approach. So the experts of the process, here the trainees at Honig, they can actually explain the processes directly to the new trainees via this technology. So that's kind of getting the non-domain specific people out of the creation loop which speeds up this process. To realize these kind of media, you can use these kind of camera systems. You can go the expensive way, but you can also go the pocket way. So you have the device in the pocket and create kind of content anytime, any place. Actually, I'm just here in a workshop right now. We do that with healthcare personnel at the very moment. And we did that in the past also for healthcare in a project where we enable teachers to create their own virtual reality stories, virtual reality trainings. And we created a specific software for that. So it's, again, an authoring tool. It's way more high level than the one for the AR stuff. We realized that before you create a training of any kind, you make your concept about how the training should be going on. Maybe you make a script or something, or maybe use a mind map. And this is why we said, okay, well, we provide you with a tool for creating your training scenario, your concept, but we make it in a way so that this is actually the programming. So there is no further programming required. You just define your concept, and this is already understood by the training simulation system. So you only need to make the recordings, fill in the recordings in your concept, and then you're done. So it's no further step. So it's, again, addressing the educators as authors and cutting the media informatics people out of it. So basically, you'd make your concept with the Paneo VR tool. You make the recording with the 360 camera, you assign the media, and you deploy it to the platform, so the VR goggles, and then you're done. And that's a tool called Paneo VR, which you can use for free over this web page. So similar to the AR stuff, but it's easier because we now have video, which is easier than 3D modeling. So here again, the media competences are strengthened. You now have to use video, but you know about video typically, and you also know these 360 videos from Google Street View, so you're already a little bit familiar with the way of using it. And well, so it's again an authoring tool, so hopefully giving you opportunities to create new content. And for the operational challenge in the classroom, well, as 360 videos can be consumed and operated in a seated condition, it's also very compatible to a classroom setup, so you don't need to walk around and do some trainings. Obviously, there are disadvantages, so you cannot handle 3D objects and look around and investigate them from all perspectives. So it's not the full VR immersive experience that you can get, but on the other hand, you have direct visual effects of the real facilities. So it's a one-to-one reality experience, which also has advantages in some situations. So this covering like the two approaches for authoring for the didactic and implementation aspects. I just want to share at the end here some slides. There are some didactic concepts for how to create and tailor the content, for example, the MARE framework. So, so to make the connection between what to show for what kind of goals. So this is more about structuring your content. In the healthcare scenario, we used the didactic orientation for the structuring the lectures. So many people might think, okay, we go for VR training, we go for AR training, and we just have this 90-minute session of VR training or something like this. But this is not how it will work. So the better idea is having this kind of traditional classroom where you get some input, some comments on what to do. You talk about what they will have to achieve when going into the situation, and then maybe they can experience one VR simulation where they can see some expert doing it, and then they can get in the same simulation and try on their own executing the task. And then they come back to the classroom and then do some reflection. Everyone is reporting on their experiences, how they dealt with it, and so on. So you have these tiny excursions, you can say them, in VR, where you can enter these situations and play through them. So each of the excursion might only be like 5 minutes, 10 minutes, 20 minutes, but not like a 90-minute session in typical scenarios. In the CHARMING, we did real like reactor simulations for like 60 minutes. So it's like impressive complex simulation, but this is then also something that we did in like 3 years of time and not just within a week or something. So you can have the large ones, but typically, I guess we shouldn't think of always striving for these lighthouse, large-scale simulations to get a kind of dissemination of the technology in the educational field. Here's just an example how it's done in this VDPA project, where we have e-learning, traditional e-learning platform, and it's actually intermixed between the e-learning sessions, discussion sessions, and then VR exposure, and then e-learning questionnaire, and so on. So it's kind of using bits and pieces of different technologies to enable the learning. And that's basically also adding to the media competences yeah, kind of collecting that. As a summary, I haven't made any check marks here on the learning the social aspects, because it's work that we're still that's still ongoing for us, and there are several other situations where you can see these social VR installations, not so much for educational content so far, but there's some examples already. One way we are currently approaching, just to give you a glimpse of our research, is maybe a little bit strange idea of co-located non-shared spaces. That might sound a little bit strange at first, but the idea is, okay, in laboratory trainings, you typically have your own, you're supposed to do your own stuff. You need to set up your own experiment and conduct that, but in a lab, you see the others also doing stuff. If we want to replicate that in a social VR situation, creating a simulation room where we have 20 of these installations that you can see them at the same time, that would be very computationally expensive for the hardware to do all the simulations. So the idea is to have these instances that you see your own stuff. You might see the tables of the others, and you might see the others going around doing stuff. You only see their body movements because they are represented as avatars. So you can see them, you can talk to them, you see if they are currently working, they are in the flow working on something, or maybe they are a little bit orientationless because they don't know what to do next. So then they will communicate that, but by body language. And then you can have these social interactions without having the need to have these multi-user interactive scenario, right? So basically you can imagine it like this, you are in your own situation and you see the others kind of like a ghost. Yeah? So like a meta level for social interaction. So you have this feeling of socialness in learning. You see the progress. If you know, okay, step 1, they need to go in this place and do this, and then step 2, they need to go on another place. You see where everyone is in the process level, yeah. But you don't see what they are actually doing. Yeah, you just see that they are doing something, and this is easy to implement. The other way, having parallel simulations in one simulation is very complex to realize, and so this is kind of the idea that we're following, and it's quite successful actually in the first tests. Yeah, so that's basically the input I wanted to give, and if you're interested, you can find me at mixality.de, and if you're interested in some more of the projects that we realized in the CHARMING project, you can find them also on this webpage. Thank you very much.
Thank you, Thies, for this insight in some really already very advanced ways of doing that. One question that came to me immediately, and I encourage all of you to put questions in the Q&A session if you like to. You were just mentioning computational expensive. Now, would any non-recent smartphone be able to deal with these kinds of simulations? Or do I actually need to have some real computing power in my pocket?
So for the examples of the similarity to the two things that you can authorize that I've shown, this is done with standard smartphones. I think when we started with Samsung S10, and now we are at S24 or something. So they're quite decent. If you go for the video-based approach, that will run on any modern platform, like even on tablets and so on, because it's only video, so there's no really heavy computational stuff running on the devices. But if you go for these proper simulations, like with the charming, bring your own, operate your own reactor theme, then you would need a desktop PC. There we did not strive for photorealistic environments, but process realistic environments. If you go this way, then it's easier. If you want to have photorealistic simulations, then it's even more demanding. So you would need a power workstation. But well, as I'm a teacher for classes, I always go for the scalable solution, because it's, for me, it's more important to have 50 students educated at the same time, not one, although I have the hardware.
All right. Thank you, Thies. We have one comment in the chat talking about how nice this would have been during COVID, this kind of tools available. How much of this kind of research was actually, how you say, started because of the needs of COVID?
Yeah, in the charming project, we planned it, everything just before COVID, and then we started, and just right after we started, COVID came into place. So it was good, but not perfect timing. If you would have started 2 years earlier, maybe you would already have been able to use it, and then it would be more fruitful. The positive side is that now we find more people actually being interested in that, because they realized, okay, maybe it's a good idea to have it. So there was a boost during COVID of interest in that, but we were not ready with these kind of projects. Now we are ready for maybe for the next epidemic. I don't know. Maybe we still use it without an epidemic.
Let's hope we don't need an epidemic to use it. Well, thank you, Thies. Yeah. If you want to post more questions, please be so kind and do it in the FNA, while we give the floor to Daniel Cermak-Sassenrath. And Daniel, sorry if I butchered your name. Daniel works at the University in Copenhagen. His report is also from the CHARMING exercise, and it looks at making soap.
Thank you. Thank you. Let me start this. Okay, hello. Yes, my name is Daniel Cermak-Sassenrath. Welcome to my talk on a game for players to learn about the soap making process. For the record, I have been at the ITU and the Center for Digital Play for over 10 years, but at the moment I am moving to a new place. So at the moment I'm between affiliations. So let me show you what this is about. It is a game. People should play it. People should have fun. It's called Banno's Fabulous Soap Making Challenge. And the idea is that people balance enjoying their playing the game with analyzing it and learning from it. In a previous talk, somebody said that people learn without noticing, and I would say people should notice, right? They can make a decision to analyze this stuff and learn from it, and experiment and explore. And this is also the basic idea. This should be explorative play and learning. And there are many other educational games, but this is the basic idea, right? For people to try out how to make soap and learn from it. This is a resource managing game, and there are many others. I will briefly show other games that do something similar, much more complicated stuff, of course. And our target audience are young adults, and this is not meant as part of any school curriculum, but it should, you know, be attractive as a game to play outside of school. And it has been also designed within the Charming project by Jessica, Serkan, Chioma, and me. And again, there is the website for Charming. And there's also links to the game if you want to give it a try. Just to briefly introduce the game, you see the two screens here. Wait a second, we have... Whoa, okay, right, okay, here we go. Oh, there's a new toolbar. Okay, good. So we have this is the main thing, the laboratory where people produce soap, hopefully, and for all their needs, what they need to do this, the equipment and the raw materials they can get in the shop. So this is, you know, this is not super complex. This is how the game works. The basic idea is, how do I remove these scribbles again? Well, okay, so ignore these. The basic idea is that digital games are so super popular and people spend so much time playing them, and it would be great to channel some of this energy to something, you know, where people can learn useful stuff. And these are the player numbers for the last 10 years or so, and it's like over 3 billion now, however they count it, right? Computers or mobile or online or whatever they do. Okay, so now I should remove these scribbles somehow. Can I do this? Oh yes, okay, cool. So the thing about purposeful play or serious games or gamification or educational games or edu games or whatever you call them is that there's a lot of expectation and enthusiasm about it, but the results are kind of mixed so far and many hard questions remain. So this is not like uncritical received. Now, the talk outline. We will start with the game concept and then the game design, so more abstract, more concrete, then the educational outcomes, hopefully. We did an initial evaluation and I report on the results. Now it becomes interesting, right? So not only what we did, but also what worked and what didn't work. So a critical discussion of the findings and also what we are planning to do different next time. I'm from game studies, so I'm not a chemical engineer of any sort. So bear with me when I try to you know, explain what is going on in the game. So the basic idea is really to let people, players explore and learn from their own experiences. So we didn't want to make a game that teaches anybody anything, but a game where players can learn. And this seems like a rhetorical stunt, but this is really, I believe, a paradigm shift, at least in, you know, some educational games. We want to give people agency and control and build on their initiative for them to try out how to make soap and then to learn from it. And for that, we have made the game hopefully super interactive, where people have lots of stuff to do and nothing happens if they don't do anything. And all the learning content has been integrated with it. So there's anything is material, drag and drop, interactive, animations, sound, and for instance, there's no text, so no teachings coming at the player. There have been many questions, for instance, with scoping the game. So we had to make decisions on that. So for instance, we limited the game to one specific chemical process. We limited the range of equipment and materials. And of course, we also simplified how these items could interact with each other. And where there was a trade-off between accuracy and playability, we went with playability, because a game that is not played and not enjoyed, that teaches nobody anything. So rather have a game that is enjoyed rather than a game that is crap, and then nobody will even touch it. And also we have, as a resource managing game, there's no end condition, right? So people can just keep on playing or failing. But the expectation would be that players play the game and probably play it in different ways, right? Challenge themselves, try different equipment, and play it multiple times. So concrete game design. Somebody already said that there are games, similar games out there, and resource managing games. I would hope that our game is similar to some of these games. Not sure how familiar you are with these. Dish Life, the game, which is basically simulating an academic research group at a stem cell lab. There's Factorio, there's Space Cam, and IDO Research. Don't want to go into them, but there are related games which are much more extensive. Of course, our game is pretty simple. In Boelo, players plan, organize, initiate the soap making process and control and manage it over time. And there are also economic aspects. So it's not only the chemical stuff. The idea is that it's easy to do, right, and hard to master. So everything that players do is pretty obvious and trivial. Hopefully there's emerging behavior that is interesting and complex. And I already showed you the two screens here. I go back to the pen. And I already briefly explained what is going on, right? So in one game, in one screen, there's the laboratory with all the equipment and the raw materials. And in the other screen, people can get the necessary materials and equipment, new equipment, bigger equipment, and also sell the soap, right? So this is also a very simple economic simulation. The whole game is based on a constructivist educational approach and specifically Kolb's learning theory, but I will not talk about that at any length. We are hoping that the learning content is about the kettle process, and that includes the ingredients that are used, the time needed for the reaction, the multiple steps, that there are multiple steps, and the order of these steps. Effects on materials, for instance, when heating them, and the equipment used, and also the scaling of the production. And the learning should happen on multiple levels, and the one like basic level is that there are these materials and their names and equipment and all these. The order of operations briefly shown here, how to make soap, right? So there's the heating, then there's trace, then there's a curing form, and then there is soap in the end. And on the highest level, there will be then these complex patterns, hopefully emerging, of dynamic interactions. For instance, a key moment is when players have enough coins to scale up their production, right? So at some point, they have to get rid of the small scale stuff and upgrade. And this is an emerging situation, right? So and a complex situation. So here's the video. Jessica made it. I hope you can hear stuff.
Welcome to Bonus Fair, the Soap Making Challenge. I will show you how the game is played. This is the main screen, and I will just start playing. So the first screen that you will see is the shop, where you have different items. For example, you can have raw materials, but also some equipment, like the heating pot or the curing form. So in order to make soap, you will have to choose some of these items by clicking the buy button. Normally, the game starts with 250 coins. So with this, you will be able to start the business. So I will just select a couple of them, like the sunflower oil, the equipment, the heating pot, and the light solution to see what happens. And the next step is going to the lab. So let's see what happens. So now in the lab, you will see that we have the things that we bought. Just to show you, I have already two soaps to show you how what the nice items in the back, what they do. So let me drag and drop in the heating pot. You can see the item is highlighted. And once we complete these two icons, the bar starts, so this shows that the process is right. So all these rows, let's go to the shop and sell these two soaps to see what happens. So we will sell them for 120 coins, and then we will be able to get some money. So now that we go and change the buy, we will be able to buy this bubble bottle. So let's see what happens if we buy it. In the soap making process, there are two processes. So now we're doing the first one, which is the heating process to create trays. So we will actually need also a curing form, fragrance, and color for the next step. So let me go to the lab and see what happens with our trays. So you see the process is running here, and the next step is the curing form. Let me put in all the ingredients. That was the fragrance. We also have the colorant. And once this process is complete, you will be able to see how the intermediate, which is called the trace, is created. So let's see. It takes a while, so this also makes it a bit more realistic. So this first actually takes longer than what you would, but normally would take. If you're ever curious about how soap is done, just have a look. Oh, okay, now we got a trace. Let's drag it in here and see what happens. This will also take some time. In the meantime, for example, if you have some questions, you can always ask what is the process. So let me show you here. You have the oil, the lye solution, the heating process, then you will get a trace. If you mix the trace with the colorant and the fragrance, putting in a current tone, then you will get the soap. So this is what we are doing right now. Close this. And you can also just choose not to have some soap. We are now on 127, so once we sell our soap, we will be able to get some money and start making some good business. We are almost there. Then we fast forward that. And now we are there. So with the bubbles, this is what you will get. So let's sell our soap. And we get it. So I hope this was clear, and I leave you with Daniel. Thank you.
All right. Yeah, thank you. A video from Jessica. I will go quickly through the evaluation just to show you what we did and then go to the discussion. We were interested in the usability to make sure that this was actually usable by people and there's not this thing that prevents people from engaging. We were also interested in people's experience playing the game, both quantitative instruments, and then we also did a qualitative evaluation, play test, and focus groups interviews. And we did this over 2 days and 4 sessions with 14 participants. We gave them phones with the installed game, and then they played it for 20 minutes, did the questionnaires, and then there were interviews. So the usability says that this is okay usable. So there's not this dramatic thing that is preventing people from engaging. I don't want to go into detail here. And we also have user experience results. So it is okay. Scores are positive compared to benchmark applications. This is not like super amazing, right? But it is interesting that people think this is a game, right? So they rate it to be somewhat conventional, usual, conservative. So at least nobody's is rejecting it outright. So this seems like tying into people's expectations. Of course, as a game, it should be impractical and inefficient. I would hope that it is. And of course, it's also enjoyable. And it's very nice that people appreciate how easy to learn and friendly, enjoyable, and secure it is. And motivating, exciting, interesting. It's also slow. Okay, but this is not too bad actually for making an educational game. Okay, now the playtest, and I think for this discussion, this is a little bit more interesting. First of all, people interacted with each other, right? They were in a room, but it's not a multiplayer game, so everybody was playing their own thing, but they didn't compete. On the contrary, they were helping each other, right? People were sharing experiences and explaining how to do things, or how to use equipment, and some extra items that can be obtained in the shop. And people even continued playing the game after the experiment was over, and even wanted to install the game on their own phones. So this is very, very nice. And in the interviews, they described it as fun, engaging, rewarding, and even addictive, which is for a gamer, this is high praise. This is not meant that this is dangerous or whatever, but this is something that you really, really, really want to have in a game. They like the design, the style, and all that. All good. Now, my main criticism of the game and how people were playing with it is that it is rather one-dimensional. It is predictable. It is almost deterministic. One player put it, you get stuff, you cook it, you sell soap, and then you repeat. So what we should be doing in the next version of the game, we should really increase the challenge and the depth and the complexity and give people more control. And people had some ideas. Some of them interesting. Adding more stuff is probably not super interesting. This is something that gamers always want, right? They always want more stuff, so they want to make other stuff, right? I mean, this isn't happening, right? Not in this small scale game. But the idea would be to make decisions by players more meaningful, and with that I mean to have feedback loops that are more complex. At the moment, this is pretty discrete, right? So everything is going step by step, small scale. What would be nice if people had ways to play the game in different ways and to discover and to compare these approaches. So this is what we would be doing in the second version, to move away from these low-level feedback loops and offer people interesting activities all the time. Okay, now this is now the end, almost. What we want to have is the exploration, right? This is the most important thing. For exploration to be interesting, there need to be some depth to discover, right? If everything is trivial, then there's very little to explore. For instance, anybody knows Ports of Call? This is a classic business strategy game from back in the day, where one was running a shipping business, a worldwide shipping business, and this was quite extensive, and this took hours or days, right? So this was very, very detailed, and one could spend a lot of time with it. And there were different strategies to play the game. So something like this would be nice. So to have some trade-offs between different options and different ways and strategies to play the game, and also overlapping feedback loops. So this is what we want to have, and I'm explaining it here. The revised version would probably be something like Bono's soap shop. So to move away from this, we're making soap for some weird reason and then we're selling it, right? So we would locate it in a specific thing, and people would understand what a shop is doing. And here, if we add a new layer, then we would have more interesting loops, right? We would still have the lab where we would cook the soap. We would still have the shop where we would buy equipment, but we would have different loops between these locations. And that would hopefully lead to exploration on different levels, right? Strategic decisions, the making of the soap, the rearranging of merchandise in the shop, maybe other stuff that one can do in a shop, like setting prices. And we would hopefully then have more complexity and a more engaging game by giving people more agency and involve people more, right? More meaningful. And also we would probably have make things even more accessible, right? So because people know how shops work, right? They still sell stuff, so one needs to produce it, then one sells it, then one. And also it locates the thing in real life, right? So this is not like in an empty space, but this would locate soap making and selling it in a real world setting. This is it. Thank you. Happy to take questions. And also, if you want to try out the game, there is the Android version available. The iOS version is currently not available, but the Android version is available online here, and here's the link.
Oh, thank you, Daniel. Yeah, this is a lengthy thing you produced. I mean, I remember having a chance of playing one of the first versions after the online congress in 2021, when Jessica invited all of us to try it out. And the one thing I wanted at the time was I wanted more fragrances and things that did not combine. Like if you put the wrong color and the wrong fragrance together, you get a low quality soap. Right? That was what I wanted spontaneously at the time, and I guess it fits really well with your very last slide. We have two questions. Two questions in the question and answers. One is about, do you know what the participants learned from this game?
Oh, okay. I also see the other question here by Stavros saying, are you afraid that this kind of paradigm shift, experience-based learning, rather enhances the more traditional trial and error procedure? Okay, I answer live, I suppose. Yes, okay, this is a thing, right? Of course, we are building on people's experiences with games, and if when players download a game or buy a game or however they, in the old days, one had a package of like a CD or a disc, but nobody's reading the manual, and there is no manual, so people do try out these things. I hear you when you say that that might facilitate a low level of learning, or a trivial strategy like clicking everything that is moving or that is clickable, and that is not always conductive of higher level learning. And of course this will happen, but I'm convinced that people will find it more interesting to strategize, right? So clicking on stuff that is on the screen, this is one way to do it, but to play meaningfully and successfully, one would need to level up, right? And start making a plan and executing it and timing things. So I think trial and error, yes, that will happen, but it is not the end of the story. Okay, so hopefully that kind of touched on what you were looking for. Sylvia's question is analyze what the participants learned. Also answer live. Yes, we did. We did look at it sort of. At the moment, we were looking more for how people interacted and their experiences, the in-game experiences. Again, this was the initial evaluation. We will hopefully get around to make a revised version, and then we will also do more evaluations, also including learning outcomes.
All right.
Are there more questions?
Thank you. Well, if there are, but we need to relay those to the chat because we need to give Philippe a chance to present his stuff. So thank you, Daniel, for your presentation, showing us what can be done with, how do you say, very retro designs that looked really, really like the 1980s and still very modern concepts. Thank you. Next presentation will also be from the CHARMING project, and it will look at the other end of things. Instead of working on a laptop, on a phone, it's going to look at a VR, proper virtual reality system. Presented will be from Philippe Kahn, who works for ChENEXT, or actually founded ChENEXT out in Belgium. Philippe, the screen is yours.
Yeah. All right. I'll share my screen. Share. And then towards here presenting. Okay, hello. I'm Philippe Chan. And of course, this webinar, I will actually show you a live VR demo. And I hope it will work because the curse of live demos always occurs to everyone. Okay, so a little bit introduction about myself. So I'm Philippe Chan, and I'm founder of ChENEXT Technologies. I'm from Belgium, and I'm currently in Belgium, so not in Scandinavia with the Northern Lights here. And actually, last year, I graduated as a PhD in chemical engineering at the KU Leuven. And of course, when I say that I did my PhD, I always need to explain to people it's a very peculiar project because it's not the standard chemical engineering PhD where you do simulations or process intensifications. No, what I did was actually designed, developed, and investigated a virtual reality series game for chemical lab safety called VR LaboSafe game. And that was, of course, part of the ETN CHARMING project. And then I graduated, investigated. So actually, fun fact, I showed this demo of this game and the EFCE Spotlight talks in 2022. So I'm back for some reason. But yeah, in these 5 years, I really, as a chemist, before 5 years, I did my master in chemistry. And in these 5 years, I really learned how to develop in VR, how to make a game design to motivate people, but also how to design an instructional design to enhance how people learn. And that was very challenging. And during this project, I also discovered how useful VR, AR, and mixed reality is for the chemical industry. And that is why I founded the company CHENEXT Technologies. It stands for Chemical Engineering Extended Reality Technologies. So our mission is actually to provide XR applications to bring continuous and exclusive support for the chemical industry process industry, but also to schools who provide chemical engineering, for example, as well. In that case, we design and develop these applications specifically for them so that it satisfies their specific needs for chemical engineering, thus making processes more safer, more efficient, and more sustainable for their company. And then in the vision of this company is that we would like to become the first choice XR provider for the chemical companies and also schools that are seeking for this accelerating to digitalization. And what I will show you will definitely accelerated digitalization. But of course, before we design and develop some applications, we always need to consider what are the challenges and the problematic problems that we need to solve in education. So for one example, I've learned what I've heard from a lot of people is that they don't really have the real experience of a chemical plant in schools. They see videos, they look at books, they look at pictures, some chemical plant visits now and then, but not really the real experience of working inside it. Of course, it's right, because the school is not a chemical plant, right? So how do we actually bring this kind of real experience of a chemical plant towards students? That's one question. Also, the nature of chemical engineering and chemistry is always very complex and it's really hard to learn. For example, here you have a 2D diagram of a P&ID system of a chemical distillation plant, and it's really overwhelming and really hard to actually see this and connect it to the real world. So you don't have this connection of the real world chemical plant and the 2D schematic. In fact, this 2D schematic actually describes the three-dimensional world of a chemical plant that is really hard to have link. So what can we bring to students to actually link this kind of abstract 2D diagrams towards the 3D environment? That's also a question. And then, of course, the companies or the schools that can afford like a pilot plant at their own place, really, it costs a lot of it costs a lot because all these equipment of valves and they need maintenance. So the real stuff is also very costly. So how can we bring this more in an affordable way towards students and companies? Of course, I will show this with a VR live demo. So I will switch my screen towards the game engine that I've used. And this environment is actually distillation plants where you can have multiple features in it. And I will show you instead of talking it through the slide. So new share, and then here, share. Okay. Then let's see if I can have this live. Resume. Yes, this works. And then I click play. So yeah, right now we're in a digital environment of a real size chemical plant. And you see that it's, when I look up, you really see the height of the distillation tower there. And for this demo, we show a small problem here. So the problem is liquid mixture in distillation column is not heating. Find out to solve the problem. So help, I don't know this. Oh, this is how a reboiler looks like in a P90. So yeah, we need to find this. Where can I find this? So then we have some tools here in the toolbox. We click here, and we need to click on the P90 app. So here you see like a virtual P90 system, and you can have different interactions with it. How to find the reboiler. So select instrumentation, and then select the reboiler. So instrumentation, I can select the reboiler here. So here I have two options. I can colorize it. So there it is. But I can also have this interaction go to. And there's actually a navigation towards the specific item on the P90 system. So when I go there, I can solve the problem. For this example, normally this is also multi-user environment, so other people can also join in and solve the problem. But for now, I cannot see my classmate, so yeah, whatever. So I cancel this navigation. So there's a problem here. So what do I need to do? Yeah, so what do I need to do is open these two valves here. So these two valves are actually controlling this control valve. So I need to come close and then open it. There you go, problem fixed. But yeah, this demo actually shows you multiple features that is really handy to have during learning about your chemical plants. For example, the P90 system, I can actually color everything and have a navigation towards anything that I want. So for example, this valve, I can know the exact location of this particular component. Or for example, here, when I show another toolbox tool is a scanner, like in the reality, all those pipes and pipelines have the same color, it's metal or insulated. But when I select one of those pipelines with a scanner tool and I colorize it, I can literally see where these pipelines go. So this pipeline comes towards there, and if we look at the P90 system again, it's actually the reflux system that goes back to the distillation column. So actually this thing you cannot really do in real life, right? You cannot paint pipelines with particular color, but this particular action is useful for people trying to learn about their chemical plant. Also, other example is here, a tool called XR Ray Vision. When I click this and activate it, you can actually see all the pipelines, their flow as well. And you can here, for this example, you can also see how inside of the distillation column works. So you have here the bubble cap, stacks, trays, and then you can see how the pipeline flow goes. So this is also a very neat tool to have an XR vision in the XR. For example, another tool, but also particularly not only for learning, is the annotation tool. So here, if I click the annotation, and let's say I want to have like a definitely is useful for turnarounds during plants. The plant needs to go under maintenance. So there's some scheduling and planning that needs to be required to do this. So for example, I put here a cube to say like, oh yeah, this part we need a crane for this, and then have an annotation, need a construction crane here, and this you can actually communicate to other personnel and other people in your company. Also here, for example, this control valve needs some maintenance, so we can have an annotation tool here, and actually see like, oh, maintenance of this control valve is needed. And this will save up a lot of time of turnaround management and scheduling. So yeah, this is a demo. The application for this example, the training platform is still under development, and not so yeah, we're still looking for collaborators to actually build this on the next level. So I have some time. I'll go to my presentations again. New share and back to my presentation. Yeah. So yeah, as I said, it's still under development, and we're looking for collaborators to actually get to the next level with the specific tools that the chemical companies and schools actually need. But of course, XR is not only for learning and training, right? XR can be used for everything else. And that's also the vision that we have in the company, is that we cover the whole plant life cycle with XR products. So for example, here in the conceptual design and basic engineering, we can have like an AR plant designing tool that you can you design your plants with particular AR objects. Or for example, here in detailed engineering and construction phase, you can have the XR plant design review, the thing that I showed with annotations. Then you can put up, oh yeah, this indicator is too low. So actually in VR, you have the full 3D scalability that you don't have with 2D screens, right? In VR, you can actually have this kind of high and low 3D space. So that's a very nice, neat thing to have of this technology. Or for example, of course, during construction, even during construction and commissioning, you can train your operators before the plant is even built. So when they are building, you can actually use the 3D models and make a VR operator training. And this training can be last for the operations phase or decommissioning phase as well. Operations phase is a long time. It can go to 40, 50 years, and they still use the same technology for these training. And also, so these examples are all homemade. We made it themselves with Unity, and we can when we have the 3D models, we can always use the 3D assets over and over again. So for this example, you can reuse these 3D models that you've built in the design phase, and also can be used for other phases of the plant's life cycle. Or here, very important is the navigation, because you need to have a link of the 2D schematics towards the chemical plants in 3D. So this is what we are doing. And of course, there's a problem in XR for now, is like Thies said, is content. Software is needed. We have the hardware, we have the MetaQuest, Apple Vision Pro, we have all these XR devices, but we definitely need software for this. And this is what my company brings, is the software towards the chemical companies and schools for chemical engineering. Yes, so this is what we're doing, and I've started my company in July last year. So we really want to try to scale up in these coming years. So yeah, if you're interested in this VR training platform, let us know. Fill in this form, scan the QR code and fill in the form that you're interested in it, and then we will look at it and we'll update you about the training platform. You can also contact me through LinkedIn or through my email page. So scan this QR code, connect with me, and I will give you more information if you really have the questions for it. Okay. That's it. Thank you. How can I stop the sharing?
Oh, you can't hear me. Thank you, Philippe.
Yeah.
Thank you for showing us what can be done between P&I diagrams and real 3D steel and concrete models. We have a comment and a question for you. Now, the comment is, from Carla, and basically says, hey, even something as nice as this cannot replace plant visits and connecting to the real industrial world. And I guess that's a non-contest comment. Yep, it gives us new tools. It doesn't mean that you don't have to do and smell actually what a chemical plant
no,
smells
indeed,
like.
it's not a replacement. It's an add-on towards education. So you can still do plant visits, but you have this kind of 3D environment also ready for at any time that you like. Yeah,
and the second is actually a question. For this kind of VR tool, do you actually need VR goggles, or is that something that you can do on 2D screens as well?
Like you have different headsets and different devices. Of course, there are drawbacks and advantages of each device. Like a VR headset is the advantage that you have 3D vision of everything, so you can also have high-low the 3D space, where you don't really have with 2D screens and mobile devices. But mobile devices and 2D screens are really affordable. Everyone has this. Maybe in the future, people will have the VR headset as well. But for now, you have different drawbacks and advantages. Also, mobile is very low performance because of their mobile.
Yep. So takes really clever algorithms to do these things on a mobile phone. Yep. Yeah, absolutely. All right. If there are more questions, please do post them in the question and answer session. We're right on time now. No, we still have about 3 minutes. So if you have a question,
ask me some questions if you have.
So we'll wait for 2 seconds to see whether somebody wants to type. And if
we can do another demo quickly.
No. If that's not the case, then thank you, Philippe. And we'll just move on to Johannes. Johannes Boelo is from the University of Natural Resources and Life Sciences in Vienna. And he's going to show us the work he's done doing surveying, basically, digitalization in education. Johannes, the screen is yours.
Yeah, thank you very much, Hermann. I think, I hope everybody can hear me all right. If not, please let me know. So I would like to thank everybody for being here, in fact, because I'm not a chemical engineer. I'm a biotechnologist and bioprocess engineer by training. But I hope the survey that we conducted can still be of some help and insight for you people. So the title, in fact, would probably be better: Digital Transformation and Education, rather than Digitalization in Education, but anyway. First of all, I would like to thank all the people involved in the work that we've done, specifically the partners that were most helpful when conducting the interviews. Not all of them are listed here. Some of them wanted to remain anonymous, but I would definitely like to thank all the organizations that supported us in the survey. I'm not a chemical engineer. I'm also not an educationalist. I'm not a data scientist. So when it comes to the topic of digital transformation, this is not my natural comfort zone, and I'm learning by doing what you're seeing here. So please, if I overlook something, if you think that some aspects should be included, let me know. What I would like to present to you in the next 15 minutes or so is first the background, the motivation, why we think that a need for synchronization of digital transformation and education is necessary. Then I will spend most of the time of the presentation talking about a manuscript that is more specifically a survey that we did on the topic of digitalization triggered change in both working environments and education. And I will give a brief input about an information hub that we plan to set up, as well as a training course. So starting with the topic, why do we need some synchronization and digital transformation in education? Well, I guess all of you know that most of the devices and equipment that we're using, be it in chemical engineering or in biotechnology, are controlled by computers. Also, most of the documents that we use in teaching are available in a digital format, and even the lectures and courses themselves have been largely digitalized, especially being triggered by the 2019 to 2022 COVID pandemic. However, if we're looking at what it takes to handle data and to connect them, analyze them, etc., there's little content in the chemical or in many chemical engineering and biotechnology curricula that would allow the students to get to know how to do these things. Also, we see quite a lack of structured teaching in terms of data literacy. For example, some organizations consider banning any type of next generation AI tools. And the question is also, how do we train our students in terms of exploiting the capabilities of, for example, LLM? And I think we've seen quite some interesting input on that earlier today by Christopher. And I'm not sure if this is really rolled out in breadth. Personally, being from Germany, now working in Austria, admittedly, two countries that are maybe not at the forefront of implementing digital transformation. I think what we've seen today is probably really the forefront and not the common thing. So I guess we need to catch up here. And maybe just to give you some flavor of this, and allow me maybe to diverge for a minute or two. If you look at, for example, ChatGPT, and you ask it, what do you lack to become a full AI? Well, you get some answers like, it's just a language model. It provides you with a definition of AI, but not really correlates to the initial question, and some generic statements are being given. Now, if you ask it further, what does ChatGPT answer if the answer is not known or uncertain? It will claim, it will let you know that it doesn't know. And if you put that to a test, for example, by asking how many people perished in the 2021 ongoing SARS-CoV pandemic, it will give you what I would think quite an okay-ish answer, in that it will tell you, I don't know, but you can inform yourself someplace else. If then you go ahead and be a bit more, say, aggressive, and ask, okay, why would ChatGPT reference some non-existing publications, for example, it would answer that the data might be outdated, or that the context was ambiguous, or there might be a programming error. However, how do we expect our students to identify such limitations and to recognize them? And that brings me back to the previous point, that is, how do we train our students to use such tools responsibly? And I think ultimately, if we look at the curricula in breadth, then we find that these digital solutions are probably not to their full potential implemented in the curricula. And therefore, the hypothesis was that we need a change in both the contents and the methods in the curricula. And for that, we envisaged to come up with 3 action items. The first one being the perspectives manuscript, that is a series of interviews with experts that you're going to hear more about in a couple of minutes. And then the second one was an information hub to exchange, say, best practices. And on the long term, we want to set up a training course to ensure that people are being informed how they can implement digital transformation, for example, in their teaching activities. And if I say we, this is the DECIMA, the German Society for Chemical Engineering and Biotechnology. And now I would like to start with this perspectives manuscript on digitalization triggered change in chemical engineering and biotechnology. The aim here was to identify the challenges, potentials, and expected change that digital transformation would have, and specifically identify competence profiles that would be necessary or that would be requested by the employers of our students. And on the other hand, the implications that that has on the teaching methods that we use, ultimately and hopefully coming up with suggestions on how to synchronize these changes in competence profiles and potentials for digitalization in teaching. The methods that we used were twofold. So we started things with a method that's called World Coffee or World Cafe, which is essentially a workshop where you have rotating groups of people that can, in an alternating way, augment the discussion and add pieces of information to the topic that is being discussed. This is an explorative technique to identify what could be interesting topics to further investigate. And the second method was that we conducted expert interviews with people from the industry, from academia, but also professionals really working in didactics and education. It was not structured or a questionnaire, but rather a semi-structured interviews that we conducted. And some more details on these interviews. We asked the people on the digitalization triggered change in the work environment, for example, the key changes, the new competences required, and did so in an analogous way for the teaching environment, again, looking for key changes, but also for triggers that would trigger teachers to initiate a change in their formats. Ultimately, also for any way that the interviewees would see how we can synchronize the digitalization triggered changes in a work environment and in teaching. Now, the results of the World Café were quite diverse. In the beginning, it was essentially identifying, or the need for identifying competences required to act in a digitalized working environment. Similarly, for digital teaching environments in universities and how they can be synchronized. And this is essentially what I just presented you on the previous slide, what we asked the interviewers about. The other things were, say, beyond what could easily be done in an interview style of investigation. It's more of an interaction that is required with policymakers, for example, to foster the interaction between universities and schools and other education organizations. Then also to establish quantitative parameters to assess the impact of any change that would be implemented, for example, in the teaching and in the curricula. Now, coming to the results of the interviews, many of the interviewers stated two very general things. And the first one was that any attempt to act or react on digital transformation was more in a reactive way and not in a proactive way. Also, they stressed that the implementation of the digitalization triggered changes could be too much for small to medium enterprises to implement, for example, through in-house trainings, which supported us in our view that an external training, which was the third action item I presented to you earlier, was actually a good idea. Now, looking at these specific results, the things that the interviewers mentioned first was probably the usual suspects, that is the new tools that are available, for example, cloud solutions and others. What was interesting is that they also mentioned the digitalized workflows, which they perceived as potential time-saving changes. However, they also stressed that in many cases, these digitalized workflows were only implemented partially, that is, ultimately creating more efforts than maybe the initial paperwork-based workflows. Also, and that's maybe more interesting in the context of education, they mentioned that they would set up internal academies to train their staff, for example, in the application of new tools. Then when it comes to application, they mentioned that augmented reality, which we've seen in the presentations by Philippe and Thies, are interesting new opportunities for them, and that they would use to an extended or to more extent process models and digital twins. However, they also indicated several bottlenecks. For example, one of the company representatives mentioned that they estimate to invest about 200 to 300 hours of teaching for each individual employee until they're ready to use, for example, augmented reality tools or new process modeling tools. Furthermore, they stressed that many of the employees were, say, not so open-minded in terms of the new digital tools that they could implement because, for example, they just didn't look like the old Excel sheets they were used to, and that was preventing them from implementing, say, the options and potentials of the new digitalized tools to a full. Then it came to the the profiles that employees or employers were expecting from their employees. On one hand, they said that there was a decreasing demand to generate new data and in terms of routine activities. However, even asking them what a routine activity was, it was quite difficult for them to point that out. So that term remained quite fuzzy. When asked for what are lacking or diminishing abilities, interestingly, what came up was that many people perceived that employees had a eroding attention span, and also they were not that able to structure documents and design documents in the way that was required. Also, they said that it was not necessary, or that in general practical abilities, the relevance of practical abilities was diminishing, and also the practical abilities that the employees would bring along would diminish. But that wasn't seen as such a major concern, because some of the companies had set up in-house knowledge transfer routines. For example, the in-house academy that I mentioned before, and that is what they mentioned. They were setting up really in-house knowledge transfer. I was wondering at that stage how affordable that is, again, for small to medium enterprises, because mostly it was large companies mentioning that they were setting up such knowledge transfer. Again, when it comes to the employees, there was quite a list of expectations and increasing demands that was formulated by the interviewees. For example, which is more in a team working context, was that they were expecting that employees would appreciate the equality of work between different types of employees, for example, engineers, data scientists, etc. Also, they were expecting that digital transformation could free up some time for more creativity of their employees, and that was something that they were looking for. That is the things that probably artificial intelligence cannot reproduce or provide at the moment. Another very important thing for them was data mindedness, and I think one of the interviewees gave a very good example. So most of the engineers and scientists are very well trained in labeling physical things. Like if you're having a certain chemical, it's very well established that the container has to be labeled in terms of what it contains, when it was prepared, which safety regulations apply, etc. However, if you look at the equivalent on the data sphere, that is not so much established. For example, data are there, maybe data are stored, but the file names are a mess. The naming is inconsistent. There are no version numbers existing. Metadata, which is super critical for a retrospective analysis of the data, are often missing or not reported. And so that was really a critical point. Along that way, they identified that digital literacy was, say, only established to a limiting extent, and that was something they were really looking for. Another very interesting item, I think, was that many of them asked that people are trained in co-working with artificial intelligence. For example, what we have heard in Christopher's talk, that was really something that people were looking for, and also for the flexibility of their employees, for T-shaped learning profiles. That is, even though you have been trained as a chemical engineer, you are open enough to branch out into something more data science related or biotechnology related, or whatever it is that your specific job requires. However, the list is still not finished in terms of what is necessary for personal competences, and more on the data competences level, they were asking that employees are able to assess AI results, probably in the context of what we discussed earlier, like how reliable are these results, how much sense does it make to apply them in a specific context. Also I'm going back one slide, in the context of data mindedness, they also stated that data standardization, for example, in between different devices, amongst different teams, is very important. And that does include the structured reporting, structured assessment of metadata. Interestingly, and that is also something that I found very interesting in Christopher's talk earlier today. Many of them mentioned that they would expect programming skills from their employees. And personally, I found, okay, do they really need programming skills, or based on the available AI solution or AI support that we have, is it really a meta level of programming that is understand if the snippets of code that an AI may spit out do make sense and how to interconnect them? All in all, what you can see is that many of these competences move out of the classical chemical engineering or bioprocess engineering field more into the mathematics, data science, and informatics area. Now, if it comes to the curricula, being asked about those, because the interviewer stated quite a lot of new items, new competences that they would ask for, that their employees can master. I was asking them, okay, how can we disinvest in on the educational part? So like, which contents can we remove to make space or to open up spaces for these new contents? And that question mostly remained unanswered, probably because it's quite a sensitive thing. However, maybe as some food for thought, if I look at it and maybe oversimplifying it, back in the days, our ancestors were pretty much relying on knowledge how to build an arrow and the bow, a functional arrow and the bow to go hunting. But along the way to the time now, this knowledge has completely lost its meaning. And I think what we need to do is really to think of a way how we can identify obsolete knowledge or maybe content that is not relevant anymore and be removed from the curriculum. What was also stressed is that self-learning abilities are highly relevant in the context of digital transformation. However, they are seldomly part of the educational training. When it comes to decreasing demand in terms of competences, some people mentioned that it would be the manual abilities. And I don't know, Hermann, how much time do I have left? Like 5 minutes?
About 3 minutes.
3 minutes, okay. I'll come to a close. So that was controversial because some claimed it's important, others said it's maybe not that that's relevant. Yeah, I can skip that for the sake of time. So when it comes to the synchronization of work and teaching environments, what is probably important is the individualized learning approaches that digitalization facilitates. So we can use the availability of online contents to allow people to individualize, to customize their learning outcomes. And then coming maybe to the summary. So the summary of the interviews is that we need quantitative surveys to better understand which digitalized teaching formats can have an impact. We need to identify the content that can be removed from the curricula. We need an overarching concept for the competences that we want to convey. And we need some standardized non-proprietary data formats for exchange, and ultimately a systematic and systemic support for this transformation. And with that, in the interest of time, I'm going to skip the rest of the slides and thank you for your attention.
Well, thank you, Johannes. Well, 3 minutes is longer than that, but hey, not going to complain about that. If you have any questions, please do post them in the question and answer session, or if you are a presenter and cannot, just open your microphone and ask. If there is not, I have a question concerning this very interesting question you had about what can be disinvested in education. And I guess everybody agrees that we have to disinvest something, and everybody wants to agree other people's stuff. What is your personal opinion on that? What can we disinvest?
Yeah, that's a very good question. Before I give my answer, the only answer I got from my interviewees was intensification. That is, try to merge for example, data analytics into the regular lecture contents, which seems a bit overwhelming to the students, especially if you start to do that on a bachelor level, maybe. Personally, I think what we need is we need the courage to look into the mirror and ask ourselves, okay, what is the content that I maybe like, but if I'm being honest to myself, I can say, okay, this is probably not what we need in the future. For example, what Christopher mentioned earlier this morning, many people now ask, okay, we need to upskill our students in programming skills, but do they really need to go through an entire education and learn an entire programming language, or do they need to understand how do I stitch together individual code snippets? How can I understand if the code is right? How are parameters being passed from one part of the code to another part of the code? So what is really the depth of the programming skills that we need, and then maybe cut down on the essentials, and also probably look at the techniques that we present to the students, and then think of, is this really what we need them to learn now, or is this something that they can easily learn on the job? And we should more focus on the methods rather than on the specific contents. This is definitely controversial.
It sure is, and it reminds me a lot on my first interactions with computers, where the standard programming was still in assembler. So we learned about peaks and pokes, and actually high-level programming languages like C were just barely coming, and certainly high schools did not have them available. So I trust most of us have never learned how to program assembler. So maybe in future, we all will learn how to program using a large language model instead of doing actual Fortran coding. All right, since I do see no other questions, thank you, Johannes. And we will pass on to the final presentation of this Spotlight Talk session. It's going to be from Cheryl Bodner from Rowan University in Glassboro in the US. And as I said, she's the one where the sun settles last, so she had to be the last one here. But my real reason is she has the most interesting job title, because it says Experimental Engineering Education. And I'm really intrigued to hear what you do in experimental engineering education. Cheryl.
Thank you very much for the introduction, Herman. I'm just going to share my screen. Okay.
Yep.
Good. So we will get started now. So my name is Cheryl Bodner, and I'm an associate professor in the Experiential Engineering Education Department at Rowan University. And I'm going to be presenting to you today on our work on Contents Under Pressure, which is a digital game that I developed with collaborators Daniel Anastasio, Daniel Berkey, Matthew Cooper, and Filament Games was our game design partner. So as chemical engineering educators, we're all aware that we need to prepare our students for the future. And I think that's been a concurrent theme that's occurred throughout the Spotlight series this morning. The idea of preparing our students for what they're going to face as they enter into chemical plants, the decisions that they're going to need to make, how they're going to need to coordinate and work with others, understanding the material and the equipment. And so there are a variety of different teaching approaches that we can use in order to instill this information in our students. There's traditional lecturing, but the research has shown in the field that this only leads to a 5% retention rate and cannot have the same interest and passion among students as some other methods. So active learning has come out a lot more in the literature recently because it has a higher retention rate based on studies that have been performed. And it shows that students have an increased interest and passion for activities that they're actively engaging in. Now, active learning has a variety of different types of approaches that you can use in the classroom. Many are aware of collaborative learning, so grouping your students into teams, having discussions in that way. You can also do problem-based learning where you provide them the problem in front. But what I'm going to focus on as part of this talk is really game-based learning. So how can we use games as a tool to engage our students in the classroom? So you might ask what makes a good game. So games have the ability to push individuals to work to the edge of their capabilities. It's kind of finding that sweet spot where you are willing to work beyond what you might normally do in order to attain the goal, but you're not going beyond your capabilities. So you don't get to that point of frustration. So it's a very interesting and intricate balance in order to get the right conduit in a game. Games also have 3 key criteria. So they're designed with a set goal. So you need to be able to actually achieve something by the time you are finished playing through with the game. And another way that they employ these characteristics is by providing rules for the players to follow. So they need to understand how they can get to achieving that goal and what they're allowed to do versus what they're not allowed to do. And then finally, they provide players with immediate feedback. So you can know whether you're moving in the right direction. So with Daniel's game on the soap, you can tell right away if you're missing a component or something in order to be able to produce that soap. It's giving you that feedback so you know how to proceed and move ahead. So our game is called Contents Under Pressure, and you can see a screenshot of the game here. It is basically putting you in the role as a senior engineer working at a chemical plant facility. You are in charge of overseeing 3 different chemical plant operators that come in. Emily on the screen here is one of them. And then you're reporting to your boss, who comes in to check in on your progress at different points throughout the game narrative. There's a safety plant inspector that comes in to see how the chemical plant is operating. And then throughout the course of this 15-day game narrative, you hear about this impending hurricane that's coming out towards your chemical plant facility. So you're making decisions with this weather event. And so there's a weather reporter that will stop by and give you updates on what's happening in terms of the storm. And then you also receive phone calls from your adopted daughter. You can see a picture of her on your desk there, asking you about whether you're going to attend her piano recital and elements like that. And so the game is designed really to help individuals start thinking through the choices and judgments that they would make in a process safety context. Each character that comes in presents the individual with a prompt, and then you have 2 choices that are shown at the bottom. And as you hover over one of the choices, it will actually light up the meters that are present at the top of the screen. And this is where you get your immediate feedback. So you're being charted on how much time you have left in that day of gameplay. Shown by the clock, but then you're also measured in terms of how well your plant is doing in terms of safety, what your personal reputation is, how are the individuals seeing you and your choices that you're making, and then the output of the plant. So that's both budget as well as production. So how much are you actually producing at the end of the day? All of those meters are rated based on this happy face scale that's shown to the right, where you can be very sad, as shown by the red happy face at the bottom, all the way to super happy, things are going well, shown by the bright blue happy face at the top. Contents Under Pressure also has a number of reflection prompts that are built into it. And this is to have the participant think a little bit more deeply about factors that might have influenced the choice that they were making at that time. And so these prompts, as I will talk about shortly, are correlated back to a theoretical framework on moral reasoning. And then we have the individuals rate them based on whether they're very irrelevant all the way to very relevant. So I just wanted to go through some results on 2 different studies that we've done with Contents Under Pressure, so you can get an understanding of the research that backs this game. And so in the first one, we were looking at what differences exist between students' expressed moral reasoning when they take a survey. So basically a paper-based instrument that they would do in class, in comparison to interacting with contents under pressure in the digital environment. And so to give you a little bit more background on the theoretical framing of the game, we used moral reasoning, which was based on Kohlberg's moral development theory. And it's basically the transformations that occur in your form or structure of thought as you are growing up as an individual. And it starts really in the pre-conventional space. And so originally, in terms of your moral reasoning, you're really self-focused. You can think about this as a child where you're like, oh, I want to get more of this cookie or treat, or I want to be able to have access to this toy. It's very focused on where you are and the dimensions that impact yourself. Now, as you develop, you start to fold in conventional reasoning, which is a focus beyond just your immediate self, more to your friends, your family. It can do with time or money. So elements associated with that might be, if I lose my job, how would this impact my ability to pay for my home or to be able to support my family members? Then finally, as you get further in development, you get into the post-conventional reasoning space. And in this level, you're thinking more about society as a whole, you're thinking about the environment. So as a senior plant engineer, you might be thinking about, well, what are the implications associated with my judgments and how this might affect the local community? or the runoff from my plant, is there the possibility that this can contaminate the environment? Now, you don't truly ever get to a fully post-conventional stage in terms of moral reasoning. And even when you're at the outer layers of reasoning, you tend to use all the different levels as your approach to judgment, but it's basically a progression as you're moving forward. So the study we did was in fall of 2019, and we did this intervention curriculum, which involved contents under pressure built into either a senior chemical engineering design course or a process safety course. And this was across 3 different institutions at the United States. And we compared contents under pressure data to data that was collected on the survey instrument, which is called the EPSRI, so Engineering Process Safety Research Instrument, which I'll tell you about shortly. We had 148 students total that completed both as part of our data set. And so through the instrument, we used the prompt that was most similar to the storyline that's present in contents under pressure. And we were pulling ratings that tied to that pre-conventional, conventional, and post-conventional line of reasoning from both the survey instrument and from the game. And then we did a paired t-test as well as a Bonferroni adjustment factor to account for the multiple comparisons we were making, and looked at Cohen's D for practical significance. The Engineering Process Safety Research Instrument is developed based on the Defining Issues Test 2. So this was an instrument that was developed also on Kohlberg's moral development theory, but more from the general ethics space. So it had very generalized scenarios. What we did was we took the format and the scoring approach that they used, but then built our scenarios in the process safety context. So we have a series of prompts as shown here on the screen, and then a choice that the students need to make in response to that prompt, followed by a series of anywhere from 12 to 15 considerations that they need to rate. And these considerations that are at the bottom are tied back to that theoretical framing. So they're matched directly to whether they're pre-conventional, conventional, or post-conventional, which allows us to then do that breakdown and compare it to the reflection prompts in contents under pressure. Our results from our study are shown here. What you can see is that contents under pressure actually shifts the moral reasoning of students conventional side more into the conventional and pre-conventional side. And I know this might seem surprising, right? So I think as educators, we're like, we really want to push our students into the post-conventional thinking space. But based on research that they've done on the Defining Issues Test 2, they've actually found that most individuals that are in higher education settings, so at that stage of their life, are actually in the conventional reasoning in terms of moral development. So when we're seeing a lot of post-conventional thinking from our students, it's more likely that they're actually responding in a way that's like desirable. So they see, oh, I'm in an ethics class or I'm in a safety class, so I need to answer in the most safe way, and because the context is very relevant to them. Whereas in the game-based environment, we're actually getting at more of their realistic behaviors. We're capturing what would happen if they were in the chemical plant. And our goal is not to shift students one way or another, but through this intervention to provide them the opportunity to see where they are in their approaches and then be able to reflect on that so that they might change things moving forward. And you can see that the results are statistically significant with small to large effect sizes. So the second study I wanted to go through as part of this presentation actually looks at a comparison between senior chemical engineering students and then practitioners that are working in the field. And it's about their espoused beliefs about how they would approach process safety judgments, and then if there's a gap that exists between their beliefs and their actual behavior based on what's happening in contents under pressure. So beliefs are those things that we strongly hold, that we value, that kind of come up to the forefront in terms of what we plan on doing and moving ahead. And beliefs can be developed based on our lived shared experiences we have, such as internships you might go through as a student or your educational program, but they're also tied back to the morals that you develop as a child. Now, it's been shown that beliefs do inform behavior overall, but there are also many situations where our beliefs do not necessarily align with our behavior. And so we were interested in studying if there was a dichotomy in this space within the process safety field. We used a contextual framework, as shown here, that was based on 6 different competing criteria that influence individuals when they're making process safety judgments. All of these criteria were selected based on elements that not only relate to the process safety environment, but also to external fields. So in the airline industry, the healthcare industry, and construction industry, all of these factors weigh in on how you make judgments. Leadership is basically how you lead others in your organization, but also how you report back to management. Production is based on how much you're actually producing. Relationships is relationships with your coworkers, but also thinking about relationships external to that. Safety is pretty self-explanatory. Spending is tied to your budget, and then time really has to do with amount of time in your day and how that might influence your judgment-making process. We did a 3-phase study for this. So first we conducted beliefs interviews with participants. As part of the beliefs interviews, we asked them to rank those 6 competing criteria to see which ones were most influential in their choices. And then we provided them with 5 different scenarios where they had to juxtapose those competing criteria and then decide which one would more align with their choice moving forward. Then we had the students and professionals play through the game. So they played Contents Under Pressure. And as a result of that, we could actually pull out their gameplay and how they were prioritizing those different competing criteria as they were moving through. And then after they completed the game, we had them do a follow-up reflection survey. And as part of this reflection survey, again, they were ranking those 6 competing criteria. So we were interested to see if, in retrospect, when they were reflecting on what they did in the game, were they actually able to accurately capture their behaviors? And this led to the generation of what we're calling a gap profile. And an example of that is shown here. And it's just basically those series of those 3 different rankings of the 6 competing criteria and seeing how the individuals were actually prioritizing this in terms of their judgments. We would then conclude with reconciliation interviews with the participants where they would talk through any observations that they had based on their gap profile and why they thought this might have been occurring. So the next, we went into our research question 1, which was what are engineering students or practitioners' espoused beliefs about how they would approach process safety judgments with competing criteria. And with this one, we had 2 pilot studies that we ran. So we ran them with senior chemical engineers that were in a high research institution capacity. Most of these students did not have significant work experience. And then the practitioners that participated in our pilot study, they were all in the chemical industry and most of them held safety related roles. So just keep that in mind as you're seeing the results that come up. So what we found, which we thought was really intriguing, was that students did not feel relationships had any role in the judgments that they would make. So people, interaction, all of that did not play into how they would make their judgments. And you can see this by looking at that snapshot of the gap profile from their beliefs. The students inherently were ranking relationships in like the later half or at the bottom of their competing criteria ranking. And we also have this one quote from Bradley that I'll just give you a moment to read. So it shows some empathy towards the individual, but necessarily doesn't say that that individual would really have a significant role in the choices or the decisions that were being made. With our practitioners, we actually saw a very different result. So we found that the practitioners really valued relationships and they found that it could be used to help motivate them in order to attain certain goals in their work, or it could be something that could be leveraged. So by building strong relationships with their coworkers, they could then use it to attain a goal at a later time. And you see that in general, their relationship ranking was much higher than what the students were at the belief stage. And we have this quote from Kraft that gives you a little bit of an example of how they view relationships. So our second question was what gap, if any, exists between engineering students and practitioners' espoused beliefs and behaviors. So this is looking at that full gap profile. At this time, we've been able to complete our full-scale study with students. So this is 12 senior chemical engineering students. This was from a different higher ed institution with higher research activity. And some of these students had work experience, although it was still limited in nature in comparison to what you would imagine the practitioners had. What I'd like to draw your attention to is that the students definitely prioritize safety. So that message is getting strongly through to the students. Although we did notice that they actually prioritize safety a little bit less in terms of their behaviors than they had anticipated. But on reflection, they thought that they were prioritizing safety throughout. We also saw that similar result with the relationships as to what we saw with the pilot study. So the students in general tended to deprioritize relationships or say that it wouldn't have any influence on the judgments that they were making. But when they were in that game-based environment and characters were coming in and they were hearing different scenarios, they actually prioritized relationships more than they prioritized the rest of the competing criteria. And this is fascinating because this is something that we do not tend to discuss or talk about in the chemical engineering classroom, is how relationships play into the choices that we might be making. Even on reflection afterwards, the students then started to see the value associated with relationships. So it shows that a conversation around this area could be very potentially powerful and transformative to the students. When we looked at the practitioner pilot study results, this was with the same 3 individuals because we haven't run our full-scale study to completion at this point. But when you look at their profiles, interestingly enough, you see much more consistency in terms of the beliefs to the behavior to their reflection. Both of them, and this could be because they were in safety-related roles, prioritized safety at the top and had consistency throughout. When it came to relationships, we saw consistency in the one, and then even an upscaling of relationships in the second one in terms of their behavior. So it's interesting to see the trends and the differences there with the practitioners. So just as some key takeaways, we found that Contents Under Pressure provides an authentic practice environment. So it's a safe and realistic environment to go through chemical process safety scenarios where there's no risk of harm or injury to the individuals you're working with or damage to the plant equipment. We've also found that it elicits actual behaviors versus an individual's predictive behaviors of how they might behave if they were in that type of situation. And by the nature of the judgments that we've built into this digital game, you can simulate the complexity associated with process safety judgments. So there's that nuance there, that need to respond to individuals, the time pressure that doesn't necessarily get well simulated within a classroom environment. We've also found that the espoused beliefs of our students do not necessarily always align with their chosen behavior. And so by doing a reflection type exercise, which is what the reconciliation interviews were meant to have, it provides an opportunity for individuals to understand how they're approaching these behaviors. And then when they might be in a similar situation, they might be able to reflect upon it and take a different path. Oftentimes, when you think about some of the larger engineering disasters, one of the key things is that I didn't realize that there was ethical or moral implications associated with that scenario. By doing this type of practice training in an education environment, we can better prepare our students to be aware of those situations. And then we found the role of relationships to vary based on the population. Students that had little exposure to engineering work experience discounted the impact relationships would have on their judgments, whereas practitioners actually understood how it could be leveraged and used as a motivational tool. I just want to acknowledge the National Science Foundation and Improving Undergrad STEM Education and Research in the Formation of Engineers grant, several grad students and undergrad students involved in this work, and a series of collaborators. And then if you would like Contents Under Pressure for your class or organization, you can go to this website or scan this QR code and hit the Contact Us button and fill out the form. Thank you very much.
Thank you, Gerald. That was a wonderful ride for the end of our series. If you do have questions, please feel encouraged to put them in the question and answers chat, or if you are a presenter, then you have to use the regular chat. And there is a question there. And it's about that claim you made, which says that people behave in the game more realistic than they do on paper. How do you know that that's actually realistic? When I look at my son, how he drives on the street, fortunately, he doesn't drive like he does in the games.
Yes, so I guess there is that factor in there. We think that it's more realistic just based on the other research that's been done in the ethics space. So what they've found in the ethics space is that you are basically more focused on that conventional line of reasoning when you're at that stage of development. So when you're at the university level, and we were seeing more in line with the conventional reasoning in the game. I agree. I have a teenage son myself, and when he plays the driving games, I'm like, you would never be able to drive like that if you were in the real world. But we also hope that like the game does give you that immersive quality so that you're not necessarily thinking about everything as a safety-based decision or as an ethics-based decision. I think where we run the issue with how we train individuals in approaching process safety is they're in a safety context, or they're studying a case study where they know that something went wrong safety-wise. And so they have that lens when they're making those choices. Whereas in the game, that can blur a little bit. So it's a little bit closer to what real life might be. You don't necessarily go into your work day and you're like, okay, so which safety decision am I going to face today? It's more like you're going through and making a series of judgments, and some of them have safety implications.
Yeah, thank you. There's a question from Thomas, and I had that same question. How much effort is it to go through that? I mean, it's an exercise, this game, right? And it's intended to be played through its full extension.
Yeah, so we have two versions of the game. We have one that's a single playthrough that you can do. We also have a 15-day version that we've gated off, because then it allows you to extend the life of the game or do a little bit less each time. So with a single playthrough, you can play through the game in about 2 hours and a bit. Each game of narrative, so there's 15 days of game narrative that are built in there. You can play anywhere between 5 and 7 minutes, and we'll get you through one of those 15 days. So the gated version does actually use your computer clock so that you can't go to day 2 until you get there. And we use that more for students because we like to replicate what it would be like in professional practice. Like, you're not going to go through and just sit down and do 15 days of gameplay all at once. You would have like a day and then another day. But we did design a single playthrough version for the purpose of the industry practitioners we were working with, because it wouldn't be very valuable for them if they had to come back 15 days in a row to do the game. So we have both versions.
I guess so, yeah. If you get industry practitioners to do any additional education, you really have to grab them at that moment. They have to come back. It's never going to work. Okay, there is another comment from Marcel. Wonderful work indeed. Well, right, yeah, that's true. I wonder what we could see if industry co-workers would take a continuing education course with that game. Would seasoned industrial chemists also show similar results?
Yeah, so right now we're doing our full-scale practitioner study. We have a total of 14 practitioners from a variety of different chemical plant industries that have gone through the game, and we're starting to analyze the results. But we are seeing more consistency in the people from industry than we were seeing with the students. But we are curious to look into more detail about their reflections and their choices. So more data to come soon.
All right. Just going to cross-check whether there is another question. If not, I get to ask mine. Now, active learning exercises are always more work for the students than passive ones. I remember students in Delft where they had a really interesting concept of like 30-minute lectures and then 45-minute group works, and the students hated it. They hated it. It was really successful as far as learning, but they still hated it. So how many of these games can a student curricula actually carry?
I think it's like any type of curriculum. It needs to be used in moderation. So I wouldn't suggest that you use a game every single class period. The students will get annoyed with it and frustrated, and they're like, I don't want to learn this way. But I think if you're using 2 to 3 kind of like strategic game-based exercises throughout your entire curriculum, they can have value. You can use games as like review tools before exams, that type of thing. I've used that a lot. I've actually also done some game-based learning in the chemical engineering space where instead of a typical design project, I've had students take a chemical process and turn it into a board game that they would use as a method to teach other students about that particular process. And they were doing calculation-based questions so that they would actually bring in the content of the course as well as like elements associated with that particular process. So that can be helpful.
All right. Thank you, Cheryl. Thank you again. I see no more questions. Last chance. If that's not the case, then thank you to all the presenters of today, particularly those who had to work on the very edges of the working day. Thank you for joining us. Thank you everybody who was in the call listening and participating with questions. You will have a chance to see this again if you have to, if you need to recheck, or if you had been out to replenish your coffee supply. It will be published on the EFCE YouTube channel in due time, not tomorrow morning, nope. But sometime before summer, I'm quite sure. Martin is laughing, so yeah, that will work. And with this, thank you all for being here. Thank you, Boelo. Thank you for all the presenters. Thank you, Martin. And all of you, have a good day. And those of you who are at the end of their working day, maybe don't go into a video game right now. Take a little walk and let this settle. Goodbye.